All right, starting up the stream. And oh, I got a transcoder today. Or did I? Weird. I guess I did, but the way I'm looking at it, I have to scroll through the list to see that. Okay. Hey there, Red Rampage Crumpet. You weren't waiting right at the Twitch loading screen for me to start streaming, were you? Let's see. I think I hit all the right buttons, so should be good to go. Tired Beaver, hello. You've been here for years waiting for me to come back. Wow. I am impressed you've been waiting for so long. So this is like the second stream in like a year and a half. I'm working on a programmable parser, and I think because I've been working on something pretty esoteric up until now as far as like what it can parse, I'm gonna pick something a little bit easier to understand. So let me set this up to run to show you what I have been parsing, and then we'll pick something easier like JSON. How about that? So find the stage, open folder. So I picked Slide to have my parser understand. So just like almost any audio, video, image file format, it's going to look like utter garbage, except you might see a few bits here and there that give you a hint about what it is. So this is what I've been focusing on so far for my programmable parser, to understand this format. So, you know, an animated GIF or GIF, however you want to say it, has got multiple frames, and each frame is an image. And we'll see them here. We have 10 images, and we have a application extension block in front of that. So if I dig down into this, you'll see here are the actual pixel values, which are indices into a palette. And I don't yet have like a visualizer for that. But if you can imagine, if I did have a visualizer, it would show us one of the frames of this, maybe like allowing us to like pick a pixel and see what color it is. So we kind of have to take it for granted that that's the format. I could show you the actual GIF.format and kind of go through this, but you can see it's kind of complicated, right? So I figured today what I'll do is start a new format for the parser. Same program, but just another input to the parser to teach it how to understand JSON. So the parser is for any kind of format you can imagine. So the parser has its own programming language, and this is what it looks like, where you describe how to parse something. So this is how you parse a GIF, right? It says, well, we're going to parse in little endian mode. First, you'll parse a header, then a logical screen, and then a bunch of data blocks, and then a trailer, right? And in the data is where you actually have the each frame of a GIF, right? So data, one thing you can have for data is a graphic control block, and that could be a rendering block. And a rendering block can have a table-based image, and you have your image data and maybe a palette, like a color table. And the images are all compressed with LZW, so you have to first decompress them, and then you get your raw pixels, or lookup. Each pixel is like a lookup into the palette to pick the color out. So this language I kind of designed around like a C kind of language, but instead of executing instructions to make calculations and update variables, each statement in the language is telling the parser how to parse the next thing and assigning it a type, helping it understand how many bits need to be pulled out and how to and in what order. So, for example, when we get to header has an S signature 24. So S is a built-in type saying we're going to parse a string. We're going to name it signature, and it's 24 bits long. If you remember when I ran it, am I still running it? Yeah. That's what the very top of this header, this first 3 characters, these 24 bits are the signature, right? So each line is either going to be a control statement like an if, like a control flow, or it's going to be an instruction on how to parse the next thing. So yeah, let's start over with a JSON file. And now that I think about it, I don't have a JSON file, so I first have to get one. I had loaded these in advance. Let's just take the sample from Wikipedia, right? I'll just copy that, and I'm going to make a new file. And I don't know, sample.json. And I misspelled it already. All right, and then I'm going to paste the JSON. Save that. There's a JSON file, right? So if you don't know what a JSON file is, it's JavaScript object notation. So it's a typical kind of like human readable, but also pretty easy for a machine to read data structure. So it's a structure with a whole bunch of like keys and values in it. So like you can imagine this is the record for someone in an address book. Here's their first, last name, their age, their address, and you see how it's nested, like the address is itself a JSON object, right? Which has a address, city, state, all that stuff. There are different data types here. So there are like numbers, there's true, false, or Boolean, there's strings. Here's a list. So our parser has to go through fundamentally one character at a time, and that's where I had this notion of what a character is. UTF-8 is a very common format these days for how to encode a character in a file. And in the good old days, in the 60s, 70s, 80s, a character would just be 1 byte. And so you only had like up to 256 different kinds of letters or numbers. And that worked for English, but as computers went around the world, you have all sorts of different alphabets, and there's no way you could fit it in 1 byte. So these days, you have an encoding where if it's a common character like A through Z or the numbers 0 through 9, it'll fit within the range of the first 128 entries in Unicode, which is a huge index of all different alphabets around the world, right? Most common ones are first, so they'll fit in a byte. But if it's an uncommon one, like maybe a Chinese character that's very rare, it might be near the end. Or if it's an emoji, it'll be near the end. If it's like a somewhat common character, like a common, like the letter E with an accent above it, it'll probably be in one of these like middle ranges. So we're gonna have to write syntax for my parser to turn the bytes that are in the file into characters. And then once we get them into characters, we're gonna have to scan through the characters and kind of figure out, what's there. So you can imagine it would start on the first character, and it would see, oh, there's a curly brace. So that means we're going to be parsing a object, right? As opposed to if the first character was a double quote, it's a string. If the first character was a digit from 0 to 9, it would be a number. If it was the letter T, it's probably gonna be true, and it's probably gonna be null. So there's like, as we scan character to character, we'll figure out what the next thing is, and then we'll have to find like all the way to the end of it. So if we parse the first character and we see curly brace, we're gonna keep going until we get to the end curly brace, right? And everything in the middle is gonna be one big object. So we're going to be doing a lot of lookups. So like, for example, if you see the double quote in front of first name, well, we're going to have to look ahead or look up where is the next double quote, and then we'll know like the boundaries of where the string starts and ends. And then we'll parse the whole thing and say, well, the string is first name, right? And then proceed past that like we would expect, since we're on an object. The next thing is going to be a colon. We'll also need to figure out how to skip white space and all that good stuff. Yeah, tokenizer. So my parsing language doesn't have a built-in notion of tokenizing. It really has just a bunch of different built-in parsing functions that it can do, and they're very elementary. So we have string, we have unsigned integer, we have a single bit. What else do I have? I think that was all you actually need to have built in for a GIF. I think I also have like floating point number and I can't remember now. Yeah, very elementary things. So we can use UI unsigned integer as a building block for getting for defining a character. So you can imagine I'm going to have like parse the first bit. If it's a 0, then we're going to have 7 more bits, and that's one character. But if the first bit is a 1, then we got to look. Well, we're going to expect the next 2 bits. Yeah, we're going to expect the next two bits to either be 1 0 or 1 1. And if it's 1 0, then it's 2 bytes, and we'll expect that pattern. If it's 1 1, then we have to say, well, look at the fourth bit. If it's a 0 or a 1, that tells us it's either 3 or 4 bytes, right? So I think that's how I'm going to start this. So let's start a new JSON. Actually, let's make it into 2 pieces. We'll start with just utf8.fmt, right? And then to pull them in together, to pull all the formats, if we're going to have more than one together, and to say which one is the root of the whole file, I have the concept of a config file. So we'll just call this one like json.toml, because I use the toml format. And let me show you what the gif.toml was. And actually, I'm just going to copy from that. So in json.toml, we're going to say, well, the formats we have so far are utf8, and we'll be adding like the rest of JSON later. And the root will be, let's invent a syntax for like a string of characters, like char string, right? So now it means in our utf8 format, we're going to have char string. And it's going to be loop, and it's just going to be like a character, or UTF. Let's say, let's just call it char, right? And then char, let's start out with just something that's the least amount of work that we can do, which is not correct, but at least does something. We'll just say a character is an unsigned integer of, called encoding, of 8 bits. And we'll just return the encoding directly, right? So now if I go to my program and I say, let's actually open a different data file. We're going to open that JSON file. Where did I put it? Oh, I think I put it under examples instead of stage. Yeah, sample.json, right? So it can't parse it as a GIF anymore. So we have to say, instead of GIF, we're going to open JSON toml. All right, so we have 461 characters. I think probably got all the way down to the end of the file and didn't know what to do. Yeah, so it's like it didn't know to stop. So I think I need to have an instruction in the parser that knows when the end of the file is, and what we'll do is just say if, and I have a built-in called remaining, I think. If remaining is less than, let's just say if remaining is 0, break. Now that should reload automatically, and okay, it's not called remaining. Now I'm gonna have to look up what it was. I can't remember. That would be in context. So I have all my built-ins here somewhere. Here it is. Oh, it is called remaining. Did I misspell it? Let's see. Oh, right. It's got to be a function. It's got to look like a function call. I forgot about that. There we go. It loaded it. So now we have all the characters, assuming that they're exactly 8 bits long, and we've parsed every single character. So we know there's 460 of them, and you can pick any one of these, and you can see that the encoding is interpreted as the character value, right? We're good with that. You know what would be something I should get ready right now is in the sample, we should put something interesting like an emoji or like a, something that will take more than 1 byte. So let me do that, because if I don't, it's just gonna kind of be boring. Probably in this Wikipedia article, they have an example of that. This is UTF-8, right? How about JSON? There we go. Let's take the face icon, and I'm just going to literally put it here somewhere. So let's say favorite emoji. All right, so now when we see it here, did it not reload it correctly? Hold on. Samples that's weird. I guess the code that I have to automatically reload doesn't actually detect the data file changing. That'd be a bug. What am I working on? I'm working on a programmable data parser. So I'm building up the syntax right now for parsing JSON. And right now we're starting with just UTF-8 characters. Just getting the characters, and then we'll build up the syntax for it. And this is like the 50-something stream. There's a lot of work that I did beforehand to actually make this. So this parser has a built-in language to describe data, and you can like, for example, here's the GIF image format, right? And how you would describe it for my parser. And since it's kind of complicated and esoteric, I figured, hey, let's make an example where it's a little bit easier to understand, and it's going to be JSON, because JSON is fairly easy to describe what it looks like. It looks like this, right? What language is this? It's a language that I invented called DataDisintegrator format language. I can actually show you the grammar for it to prove that it really is a domain-specific language and all that. That is in parser grammar. So the top level is you have one or more formats. A format is a name, some arguments, a brace, and some statements. Statements are a chain of statements and all that stuff. You've got different kinds of statements like parse statements, ignores, look-aheads, while loops, for loops, alternate sets, bounded expressions, etc., etc. So yeah, this is like a compiler built into my program. So using the instructions that are written here, it basically says to parse the file loop. If there are no bits remaining, break out of the loop. Otherwise, for every time you go through the loop, parse one character, and here's how you parse a character. Take the next 8 bits, interpret it as an unsigned integer, and call it encoding, and return that value. So my program will compile that, and then take that, and then the JSON file I gave it, and right now it doesn't understand JSON. It only understands what I've described so far, which is UTF-8 in a loop. So it just says, okay, here's all 480 characters that it parsed out. And I can pick any one of them. We can see that it's just interpreting every byte as a character. Yeah, I made my own language. So if you are familiar with Rust and you want to make your own language, look up Lollipop and look up Logos. That's what I used. So compilers generally are in 2 big pieces. There's the parser generator part, which is the one I was kind of showing you the input to. This thing kind of describes the syntax of your language. The other part is the lexer, where you kind of describe what are the elementary tokens. So for that, I just need to show you this, I think. Yeah, so you basically say, this is a line ending. These are your reserved words. If, else, blah, 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 blah. Oh, and here's how you parse a string. Logos uses regular expressions. So if you can describe a token as a regular expression, like this is what a string looks like, this is what a floating point number looks like, here's what an integer looks like, all that stuff, then it will reduce the program that's being compiled down into those tokens, and then those tokens get matched against your grammar, which is this stuff. There's entire books and stuff about making compilers, so I'm not gonna go into it too deep, but yeah, it's a thing. It has been so long. Hey there, A Squared, how are you doing? Yeah, so if I'm going too fast, I apologize. I have a tendency to do that. Also, this is like stream number 58 of doing this thing, so unless you've been watching, I haven't streamed for a year and a half, so unless you were watching me in 2023, you're missing a ton of stuff. I do have some of it archived on YouTube, but like, I don't expect you to watch all 1,000 hours of it. I can answer questions if they're easy enough for me to answer. Otherwise, yeah, it might be a little arcane, the stuff I'm looking at. But hopefully, as I build up this syntax, you kind of get what I'm doing. So again, today I chose to teach my parser through its programming language how to parse a JSON file, because JSON file is relatively easy to approach, right? This is a JSON file. I think it's like kind of almost self-evident what the data here is, right? It's like a contact list entry of someone named John Smith, and here's their address, their phone numbers. Like, here's how you would store it in a file, and we're going to teach my parser how to parse that. And I'm first starting with, let's just take that file and just treat every 8 bits as a character, and we're just going to loop through and gobble up all those characters, and this is what we get, right? Here's the JSON file. I took the same one that was here from the Wikipedia article, and I just put it into a file. Actually, I can just jump over to the file and show you this sample, right? Here's what it looks like. And then when my program inputs it, this is the raw input, like the raw contents of the file, and this is how it interprets it. So like the first character is 123. That's the 7B, right? In decimal, it's 123. Second character, third character, etc. So I did find a bug just now in that I added the emoji thing and my program did not know to reload it, so we don't see it here. So I think I have to actually reopen the data file to see that. Yeah, okay, so now my favorite emoji, see how it's 4 characters or 4 bytes, but really it's just 1 character here? That's because this is encoded as UTF-8. See that down there in the bottom right corner? And that's why I kind of knew that we would hit that, and that's why I had this page ready to go. To encode things like emojis and other things, you might use more than 1 byte for a character. So it turns out, and emojis are usually in this range of codes, so you need 4 bytes to parse a single character if it's an emoji. So this, although it looks like 1 character, or 1 byte, it's really 4 bytes long. So in the raw, it looks like, you know, this thing, or if I can highlight it correctly. So those 4 bytes need to be parsed as a single emoji character. Right now, my parser doesn't know how to do that. It thinks that there are 4 of them, right? These 4. So we need to teach it better. And that's what I'm going to do next. Actually, not this one. So these 4 bytes need to be interpreted as 1 character, not 4 characters. Leverage AI and build something with it or show a cool use case for it. Oh, sorry, I didn't read your first question. You have a question. You're starting from where code is today and deciding to rebuild things we use today without. Well, I used to do more of that stuff. I like to say that I like to reinvent the wheel, and it's mostly just because it was fun for me. So that's really the general answer. I do what I do on stream because it's fun. And also use it as a platform for teaching and also learning from chat. Hey there, Raphael. Wonder if it's 4 bytes for emojis? Yeah, pretty sure most emojis are in the code point range, this code point range. But you could tell for sure by doing what I did, where you put an emoji in a file and then you open it in something that can show you the raw bytes, like my tool can do. So if it scares you with the way you present it. See, there we go, Nardoar. That's another reason I do this. This stuff shouldn't be scary to anybody. So hopefully I present it in a way that is more chill and less scary. But you are right that, like, why would I want to write stuff that already exists out there? If I was making a product and trying to make money, that's what I'd probably do. But I'm not trying to make a product or make money with this. This is just for fun. So hey, let's get our emoji to be parsed correctly. So I'm going to have to modify this, right? A character is not always 8 bits. So we're going to leverage what we know about UTF-8, in that the first bit tells us if it's a 0, it's 1 byte. If it's a 1, then it's not 1 byte. So we're gonna look ahead and say look ahead, which is the plus in my language, UI first bit 1, and then we're gonna say if first bit equals 0, then the encoding is 8 bits wide, right? Else, here's where it gets a little tricky, because after we've looked ahead 1 bit, it rewinds back. So we can skip that first bit by doing a minus and then do like second bit. So the second bit is it's actually, we're always going to expect the second bit to be a 1, right? So we'll want to look at the second bit and the third bit, right? It's if the third bit is a 0, then it's 2 bytes. Otherwise, it's either 3 or 4 bytes. So it's a similar thing here where we're going to go to the end. If third bit is 0, then parse it one way, else parse it another way, right? And actually, the way I did this is going to rewind, so I really can't do it this way, right? I have to have like bit. Oh, this is going to consume the bit too. So yeah, I need to do this differently. Yeah, I need to say next bits, or next. Well, first 3 bits. Really, and it's if the first 3 bits is 1 1 0, right? If it's 1 1 0, then it's that. Otherwise, it's that. So if it's 1 1 0, it's the encoding. We have to actually ignore those 3 bits, right? So actually, I don't need to look ahead, because we actually do want to consume them, right? So if we consume these first 3 bits and it's 1 1 0, then the encoding is we take the next 5 bits and then we drop 2 and expect them to be 1 0, and we take the next 6 bits after that. I do have an elif, yeah. Yeah, the plus is peaking, but it rewinds after that, so I have to do this a little bit differently. I made my own trap, in other words. So the encoding is, let's just say encoding part 1 is going to be, what did we say it was, 5 bits long? And then we're going to ignore the next 2 bits, and then encoding part 2 is 6 bits long, right? And then we're going to return encoding part. I wish if I could spell correctly. Shift left 6 plus encoding part 2, right? All right, so that's these 2 rows. Now these 2 rows are on the final one. Yeah, so I can't do an elif right away because I really need to look at the first 3 bits. Although I guess I could peek 3 bits ahead. Really, I kind of want to peek 4 bits ahead, right? Why don't I just do that? Then I can have elifs in here. So first bits. Notice in the 2 byte case, it's 1 1 1 0 corresponding. Simpler for your case, just hard code all 4 cases. Let's see what to detect. Yeah, I'm just kind of winging this right now. I have a problem with my cursor. See that? That when that starts happening, I have to reboot the virtual machine. I found, which is really annoying. Okay, this one I'm going to have to mask it. Right? I have to not use the mouse because the mouse is, I think it's else if, yeah. First bits. I guess we're masking the first 3 bits. One, 1, 0, 0, right? Right. So then I don't need this stuff. Right, so then else if first bits masked with, actually I don't need to mask them because it's either going to be 1, 1, 1, 0 or 1, 1, 1, 1. And if it's anything else, then it's not valid UTF-8, right? So we're going to want to have an else and do an error. Invalid UTF-8. All right, so it's gonna be similar to this, right? And this is a 1, right? So for the 3-byte version, we're discarding 4, 2, and 2. I forgot to discard the first 3 here, didn't I? Okay, so we're discarding the first 4 here, right? And then taking 4 and then discarding 2 and then taking another 4. No, 4, 6, and 6. Okay, so this is shift left 12, right? Why type when I can copy paste? Hope I got that right. Okay, and then the final line is we're discarding 5 bits. I can't use the mouse because the mouse is broken right now. 5, and then taking 3. And then we have an extra byte, right? And this is a shifting left 18, 12. Probably could have done this smarter, but I don't know. I'm lazy. Okay, where's my cursor? All right, 18, 12, 6, and 0, right? Okay, let's see if that worked. Nope, it didn't work. It got to the first character and barfed on the second character. It did get the first character correct, but it barfed on the second character. So what did I do wrong? I looked ahead 4 bits. Oh, this is wrong. That should just be 0, right? Yeah. Probably someone in chat noticed that. Hey there, Nightshade dude. And Meme Clear Bams. Probably someone noticed that and didn't say anything. That's fine. Wait, did I not do that? Did I just mess it up and it was correct before? It's either 0 or... Oh, wait, why did that not work? Do I need, like, parentheses here? I can't remember the order of... Yep, that was it. I don't have... I must have the order of, the order of operations a little funky in my language. All right, so hopefully, there we go. See, it interpreted that as one character with that code in there. We'd have to look up in the Unicode table to see if that code is the smiley face or the face. It probably is. See what A squared said. Notice in the two cases, 1, 1, 1, 0 corresponding to 1 byte left than 0. Oh, so you're saying I could have used the first 4 bits as like I could count the number of ones to tell how many extra bytes there are or something? Yeah, if it's a 1, then I count the number of ones until I see a 0, and then that's the number of bytes. Yeah, I mean, that would probably work too, but this way works just as well, right? Counting ones is the standard way. One thing my parser, you can tell, doesn't do is it doesn't check these ones. It just ignores them. So these might not be 1, 0, and it would pass my parser without any problem. If I wanted to do it like the right way, I would make a special format that like takes 2 bits and expects them to be 1, 0, and if it's not, then it throw an error or something. But I don't really care to do that. But hey, I think we're done with UTF-8. So I could take that and just kind of break that off as one little piece of the format done. I think I'm going to do exactly that. And we're just going to start a new format called JSON. And I'm going to move the what was in UTF-8, this character string, out and put it into JSON. And we're going to rename the char to UTF-8 char, I guess, and call this. My mouse not working correctly is bothering me. This is actually going to be the first time I try this, but because I haven't done this before, which is in my TOML file to list more than one format. I think this should work, but we'll find out. Unknown format char string. Did I not call it char? Oh, I think I just called it. No, I did call it char string. So let me try to oh, it did that while I was in the middle of editing, but it eventually got it, right? Here, I will clear the log and do one more, like save the file, and it should reload it. Yeah, it's good. So no errors. So here are the individual characters, and if I click on that, we should see that it's one UTF-8 character. So now instead of 190 characters, there's 185 because it sees that one of them is an emoji. If the mouse is bothering you, bring the cat. I know. So the thing is, like, clicking in the corner. Oh, see when I click on these bytes, it doesn't do anything. There's like a dead zone in the virtual machine. Like right around there. I can't click to the left. Clicking there does nothing. If I keep clicking on the bytes as they go up, I eventually leave the dead zone there. So like there's a dead zone here for some reason. Super annoying. But hey, rebooting is super fast, so let's just do that. While we reboot, I can see if I missed anything in chat. I don't think I missed anything other than the lessons about UTF-8. The end byte is always 10x. Yeah. Well, the intermediate bytes were also 1Bs, right? Oop, I mistyped that. Bad password. The password is Raimu. It'll do you all no good because you don't have the virtual machine that I got. Okay, now I shouldn't have my that dead zone anymore. I don't know what it is. Something wrong with the VM. See, now there's no dead zone. You can click anywhere. All right, so again, clicking on that brings us to there's the one character. Okay, so now building this up one bit at a time. We're parsing the JSON file as individual characters. And now I think the next thing to do would be to try to figure out that we're in an object by looking ahead one UTF-8 character, and if we see 123, then it's a bracket. We'll do that first, and then I'll break it by adding some white space in front, because I think technically the rules are you can have white space before the bracket. I'll restore that window, and we'll get back to JSON. This one. So it says like an object, I guess the object doesn't start with white space. So is that true? Like you can't have white space in front of the brace for a file? See what this one says. They have like a syntactical thing. This is more descriptive. I mean, I guess you can't, I guess you don't have white space in front. An object doesn't begin with optional white space. I thought it did. Because what happens if, close this guy. What happens if I'm in my JSON sample file and I put a space in front? Will it think it's no longer JSON? Oh, see, it still works. Isn't part of the object itself, it's still valid JSON. So we'll probably want to have, see, when I put that space there, my program's going to be like, oh, look, the first character, oh, well, okay, the reload thing doesn't work, but if I reopen it, the first character is no longer 123, it's a 32 or a space, right? So we might want to just build in as we're going all the places where white space might be to just scan ahead and skip them all. Let's do that. So back to JSON. Not the tom. We probably don't need the toml anymore, and we don't need this. Move this over here. I don't need my to-do list right now. We're done with UTF-8, right? There's my description. There's my wonderful description of how to parse the UTF-8 character. Done with that, right? So I guess we'll call this one, instead of char string, it's like document. And now that I've renamed that, I do need to bring the toml back because we're going to call it document. Document is going to be, let's keep the old one for posterity, char string, right? A document is going to be skipped optional white space and followed by an object, right? And then maybe some optional white space, right? And then we got to define what those mean. So optional white space, I think, is the easiest to specify. It's going to be similar kind of structure to this loop, right? Because we want to either, there are two possible delimiters for this. We either hit a character that's not white space or we don't have any more bits left. So we're going to loop until one of those things happens, right? So during the loop, if there's no more bits, we break. Otherwise, we're going to parse a character. Let's, just for ease, we'll just call it C. And then we'll say if C equals, is not equal to 32, then break, right? There are other kinds of white space we're going to have to handle, but this should do for now, right? And then we're going to define what an object is. Only one white space? Well, this will loop. So if it's 32, it'll loop back and try to get another one. So it's going to be greedy. And I guess I could make it more clear by saying optional white space means like optional white space means 0 or more white space characters. Anyway, object. We expect open brace. That's UTF-8 character, open brace. And we can have a check for this. If open brace is not equal to what's that code again? See, I can't do that because the data types aren't the same. But I can do that for now, even though I know this is going to break. Wondering why my if isn't being. I must have a syntax error here somewhere because normally that would be shown in that color. Anyway, yeah, error expected to or start of object. Then we're just let's just throw away everything that's inside of the. This is going to be very crude because it's not going to handle nested stuff yet. But just for the sake, actually, let's see. Oh, we're going to hit this one and say it's the end, aren't we? You know what we can do for now is we can count up every time we see one, and then when we see an end delimiter, we can count down. And if we count down and we reach, if we reach 0 again, we know we've balanced. So we can just have a, for now, a primitive balancing here. So we'll have level equals 1. And then say if the character, I'll have to replace, I think I'll have to replace this with the actual codes in a bit. But right now, because I don't know what they are offhand, and I won't know until it parses it. We're just keep them as strings. And that's level minus equals 1. If level equals 0, break. Right? That should work, right? This we don't need anymore because it should be properly delimited. If we've run out of bits, then an error is just fine, right? So we're just looking at characters. If another opening brace is found, then we're nesting one level deeper. If closed one is found, then we're unnesting. And if we found the last one, we break out. The only thing I don't like is it's not really balanced because I really like to have, after the end of the loop, the end brace. The other thing I can do is I could just start the level at 0 and enter the loop immediately and not have this open brace thing. That might be a little bit cleaner. Why don't we do that? It won't be as strictly enforcing that the object start with an opening brace, but we can handle that. Handle that later, right? So now, like, just naturally, it should, if there's junk that's not an opening brace, we'll end up effectively ignoring it for now. But this should still balance out right and break at the end just correctly, right? Unknown format document. Unknown format document. Oh, it has a syntax error. Minus expected on line 26. Else if hold on. Clear that. Go back and let me hit save on that one more time. Why does it say minus expected? Column 19 to 20. On line 26. Oh, do I not have a minus equal? I probably don't have a minus equal. So we'll just add -1 to it. Yeah, I probably don't have a minus equal actually. Yeah. Yeah, so let's try that. Can I? Okay, yeah, see, this is what I was worried about. I don't have a way to cast a string to an unsigned integer right now. I could add that to the language, or I can just cheat here and say, oh, I know. Well, it actually didn't parse it, did it? Why did it start at that byte? That's weird. Did I have a look ahead or something? Oh, the look ahead is eating the 7b. That's what's happening. I have to only look ahead. So we'll do this. UTF-8 char space. So basically, look ahead a character If it's a space, then parse it as a space, otherwise break. And so then we won't eat the thing after the space. There we go. So it's 123. 120. 123. I said 123, but did I read 123? Yes, I did. I don't know what the end bracket is. Is it 124? Yeah, it got to the end bracket and didn't know how to. Okay. Is it 124? If I scroll down to the end, 7b, is it going to be 7c? No, it's 7d, so it's 2 after, so it's 125. I have comments in my language, right? I don't remember, actually. Actually, I don't think I do, but I have comments in this style. So I'm going to do that for now. I might want to come back and actually allow it to be castable, because then it'd be easier to maintain this. Out of range integral type conversion attempt. Cannot parse. Oh, cast signed to unsigned. Yeah, I have to actually declare it as signed for that to work. Okay, cool. We're getting the object now. There's the object. Cool. So it properly parsed it. It didn't interpret the new line at the end because I don't have any rule to match that. If we want to see the white space, that might be fun. I can just make it not hidden. And then when we do this, we'll see there's optional white space at the beginning, right? Oh, and that's because the new line is not interpreted as white space. In fact, we should see, oh, it's collision on it because if it's not ignored, it's a name. So let's call this space before, and we'll call this space after. I think it's going to complain that the thing after is not white space. Yeah, so it says it's empty. There's no, it doesn't consider that white space. So we can fix that just by saying white space can be also 10, right? And while we're at it, it could also be, what's D again? 14? No, 13, right? Character turn. And there we go. There's our white space after, there's our white space before, and here's our object. Do you have hex literals? Yes. Would it be easier to do, you know, you're right. I could have just done hex literals. 7b, right? And 7d. That'll work too. There we go. Post a list of all Unicode designated white space is 9 through D inclusive. And a few more outside. Oh, I see that. Do we want to be exhaustive in my syntax right now? I don't know. We could at least, how about we just do the 9 through D and the 20? So, or it's greater than equal to 9 and less than or equal to 13, right? Tab is important. There we go. Now we support tab. Let's call this white space because it is not just a space, but it's a white space. All right. So we have white space before or space after and the object, right? So let's dive deeper. What's in an object? Well, looks like we have some optional white space, right? And then we have to have a string. And a string always starts with a double quote. So let's try to get that far. So we're going to have some space, and then we're either going to have the end delimiter or we're going to have a string, right? So I think what we'll do is we're going to skip everything that's not at level 1 for now. So we'll say if level is 1, we're going to treat this very differently. Because eventually we're going to get rid of this distinction between level 1 and not level 1. But right now, this allows me to both like skip inner blocks and look for the opening brace that starts us off, right? So if we're at level 1, then we're going to have some we can skip the optional no, let's keep it. Keep the optional white space. So the same kind of thing there. And I didn't copy paste correctly. So we have optional white space, and we're going to have a string, and then some middle. Actually, let's just number them. I'm going to eventually just ignore them, but I kind of want to highlight them right now. There's an equal sign, right? No, it's a colon. And then some value, right? Let's just go ahead and declare value, right? And then we have some space after. And then we might have a comma. Actually, let me think about that. If it's not a comma, then we expect an end. So we can actually use that to our advantage. Unless is the comma always optional? Let's look. Yes. So the comma always divides between things. So we can take that. You can use that to our advantage, right? We can say alt, either a comma or it is a end brace. And I'll explain what an alt is in a sec. There must not be a trailing comma, yeah. Well, it actually makes my life easier, right? So alt is a syntax in my language where we try one thing, and if it doesn't match, like if it's an error, it tries a second thing. Basically, it stops when one successfully parses, and then it assigns it's like if comma parses correctly, then this whole thing is replaced by the comma. If end brace parses correctly, the whole thing is replaced by end brace. You can have a fall through else if you want, but I don't think I need it here. I just need to declare some of this syntax. I think the way I have this set up, I can just drop this nested thing for now. I can actually just move this to be inside of value. Member or members. Yeah. Yeah, I'm just leveraging the fact that the presence of a comma tells us that we're not at the end. Let me think about this, because I don't have a way to have a control statement if end brace matches. I know what I can do. I can just say it has to be a comma, else it has to be an end brace, and then we break. That's exactly what I'm going to do. I'm starting to think that I don't need this level business anymore, because we're about to get rid of it. So what if I just say we have to start with a open brace. We don't have this level business anymore, and that's just it. That's the syntax for object. Open brace, some optional white space. I'll probably put open brace can have white space before and after it, right? Then I don't need all of this space, do I? We can just reduce this to string Actually, why don't I just build the white space into these smaller constructs? So we'll just say it's that. There's a string, colon, value, and then we either have a comma, and then we loop again, or we have an end brace and we're done, right? Yeah, we don't need this business anymore. Delete it all. I just need to fill in this other syntax here. So, oops, how did that work? How'd that happen? So, open brace. There might be some space before it, right? But then we get a character out. It has to be something. Ooh, thank you. This is what I got from. This is Raimu. Actually, let me see if I can see that. Yeah, I was just handed this. Look at that. Aren't you all jealous? I got 2 chocolate bars. All right, space before, we're gonna get a character, and that it has to be equal to we're gonna just call this open brace. Well, no, it's just C. We're not looking ahead. Okay, I was just handed something else. Fruity gummy candies, thank you. It's like someone went to Trader Joe's just now. Okay, it has to be equal to 7b. Otherwise, we'll say error. Open brace expected. All right, and then while we're at it, we can just do the end brace. Open, this should be closed, right? To balance it out. Optional white space, and it has to be D. Close brace. Expected. All right. We have open brace, close brace. Let's do, so I need string, colon, and value, and comma. Comma's easy, right? So let's do comma. Comma's like, these are all kind of similar, right? If we expect a comma next, it better be a comma, which is what exactly? It's 2C. All right, so that's comma. Actually, what am I doing? Let's do multi-cursor. Multi-cursor done. Okay. Oh, colon's easy. That's exactly the same as this. Did I confuse comma and colon? I did not. Colon is 3A. Do you have a way to make a more general expect char style thing? I'm starting to think that that might be nice. Right now, I am doing it just by repetition here. I could have this be parameterized. I could say like expect and then give it this number and this string. Maybe I'll do that in a bit. But built-in, no, I don't have that. Probably would be useful to have, right? Hey, we're already matching the open brace, right? And it just doesn't know how to do a string, and it missed the colon. It says, well, I don't see a colon there. Parameterization is fun. Should I just do that now? I kind of like giving the names to be the characters because it shows up here, opening brace, right? Kind of like this. I think I'm going to keep it for now, but we could change it later. All right, so yeah, value is the tricky one. Now I'm kind of regretting getting rid of what I had before. Wouldn't value just be an alt? It's either a string or it's, let's just list them all out. String number, object, list. That's what it is, right? Okay, so string is going to be quote, and then loop, alt, not quote, I guess. Called C, and else quote break, right? And I need my space before. I think that would work, right? I just have to have not quote. Quote and not quote. Quote character is 22. Quote expected. And there's no space before because I don't want to start eating white space characters in the middle of the string, right? Not quote. If it is equal, then quote not expected. Let's see how far I get with that. Oh, what happened? Did it die? It died. Ooh. I have a panic. There's a bug in the code. Okay. Insertion index is 10, should be less than or equal to length is 1. Wow. Okay. I didn't expect to find a bug in the program itself. In the data tree, huh? 134. That's when we're adding a row. Wait, what? Here, right? 33. Okay, it's on the insert. It's inserting index 10. Okay, so the number of children, there's only one child and it's trying to insert into index 10. Why is it doing that? All hierarchy, please. Index. I wonder how I got it into this situation. Where's it get the index? Gets the index from the row data. Weird. I guess I have no idea how I got into that situation. Should I just back up until it doesn't break again? It is a bug. It's a bug in the program. The string length 10. I think what it is it's looping through, and it's populating a whole bunch of not quotes, and then it gets to the quote at the end, because I think you're right. The first string is 10 characters long. Yeah. So these are all not quotes, and then it sees a quote, and it expects quote to be to have 9 elements already, or 10 elements already, and it's trying to insert the 11th one, but it doesn't exist. So if I gave it another name like C, it'll populate it, give it a type quote. I think that would work around it for now, but that's a nice corner case, don't you think? So object, open brace. String. Okay, it failed in string because a collision on C. Oh, I can't call it C? Well, shoot. Okay, then I know what to do. I move that out. That's what I do. I call it end quote. Probably I'll have the same problem in the, yeah, see another thing. In the other alt, I have to move this out. Okay, well, there's a bug I need to fix then in the parser, in the program itself. Hey, look at that. I got a string. I got 3 strings. Oh, it populated it in a weird way, didn't it? So they're all array, they're all vector context. So here's the first string, the first colon, and the first value, which is a string. Then we have the second string, the second colon, the second value, which is also a string, the third string, third colon, third value, which it broke because it's not a string, it's a true, not a string. The error, you know, the other thing is it's also printing out errors in the alternate syntax blocks, which is not supposed to do. Let me make sure it's open, reopen it. Yeah, see this quote not expected shouldn't actually happen. I need to suppress generation or emissions of errors when we're in alt syntaxes because they're expected actually to error. I need to make sure I remember to fix these things. Okay, what's that? To do items. If what? If an error is emitted while parsing alternate alt, do not pass error message along to the client. Hey, develop it. It is a Raimu. The Raimu is live. I'm stretching my programmable parser so that not only can it parse GIF files, but it's going to be able to parse JSON files too. You only want to suppress errors in alt when in an alt else construct. Yes. If you do truly expect one of the alts to match, no, the alts, none of them necessarily need to match. That's why we have the else. So else is a valid path. So basically this is saying we could have a comma, otherwise we're going to break. Now you could have like a colon here. This means the next thing could be either a comma or a colon, but if it's not either one, we're just going to break. So there actually is no way to get an error unless I do an error here. Help. That should pass through to the client. And that was the intent really for the else, is that when one of these has to be next, then you use the else to catch that broken invariant, right? But this is also legal, and that basically says there's never going to be an error. It might be a comma or it might be a colon, otherwise we do something else. And if you don't have an else, it's implied, it's the same as having an empty else, which means like, don't do anything. Which is sort of useless, but the break allows me to have a way to kind of say if it's not a comma, then we're done with the loop, which is exactly what I want to express with it. Yeah, it's sort of like I originally tried to make this as a try-catch thing, but I found that there's going to be cases where there are a lot of alternates where you want to try them in order until one matches. So like try variant 1, 2, 3, 4. Oh, stop, and basically stop on the first one that doesn't error out. So errors are expected as a way to go to the next alternate or the else. Maybe no else should imply else error no alt match. Well, if I wanted that, then I would be explicit. I'm thinking it's more often going to be the case that that there is no invariant broken here. It's just that just like it's used here. It's never an error. You're either going to have a comma, or you're just going to break out, and then it's gonna. If you don't have a comma, it's going to expect it to be a close brace, and there we're going to say it's not a close brace, right? So maybe we would really want to say comma or close brace expected, right? Be exactly correct in the context of an object. But yeah, so I had a what was it? What was I on? Oh yeah, so one thing I don't like about it is these names are all separate. Can I combine them by moving the contents of the loop into something else? Yes, I can. So what I can do is I can put all of this into what is it called? Is it called an element? Name value pair. Name value. Right? The situation I'm thinking of is how you're using it in the value route. You expect it to be one of those value types, but you probably want to handle when it's not. Goes down here. Oh yeah, I need to have an else. Yep, you have pointed out to me that I do want to have an error. Value. What do we want to say here? Value is not. Value couldn't be parsed? Unable to parse value? Something like that, right? That's sort of enforcing that it has to be one of these. And it's going to be the first one that matches. So in general, we would want to like make the ones that we fail earliest as possible. So ones that have delimiters in front, like these, right? So it's either going to start with that, or that, or with that. And here it's starting with a 0 to 9, right? Something like that. Actually, I guess they'll all fail on the first character. So anyway, I'll keep the comments there. What was I doing? Oh, right. Name value. This will like make it easier to see, I think, in the data view. So now it should be 3 names and values, and we have this. Actually, we know what the string is. It is the name, and this is the value, right? So name value is sort of a lame name, don't you think? Much prefer things to error when you forgot to handle something and error as fast as possible rather than silently continue, but that probably does not suit this language. I mean, you could be right, and I might find from experience as I go that I really want it to error by default if none of the alternates match. And then I would flip it around and I would have like maybe maybe instead of an else would be like some other keyword that allows it to fall through without an error. Or maybe else is what falls through without an error, and then like I have a different keyword for yeah, I don't know. Yeah, maybe if I didn't have an else, it would just error, right? See, that's one way I could do it. Where's the one where none of them are required? So here, like, I might, how do I want to do this? I need to have a position for the break. I don't know how I would do it this, but like, you know what I'm saying? Like, if an error would, maybe like this would imply that it's an error, but if I want it to be like there, it might not be any of them, then you just have an empty else or something like that. Well, yeah, I think I'll go along and learn as I go. Okay, so I don't really like the word name value. You just call it like element, and its type will be name value. Object. I'm gonna start ignoring things like open brace, close brace, but for now I'm not. This is nicer. Like we would skip the colon, right? Because we don't really care about the colon. The other thing I kind of want to do is I want the name to ignore the white space in front. So I guess the way we would do that is we'd actually just put a space before in front here and ignore it. Then that should clean it up a little bit to where the name is just a string and none of the white space in front of it, right? Same thing with value, I guess. Actually, then why don't I just move it into here? And remove it from here. There we go. So we're just kind of ignoring the white space now between things. Okay, so it doesn't know. Oh, I forgot to in my to-do list. I was on that, right? That was if a part is parsed in the else of an alt, and this is all inside a loop, we end up crashing in the data tree, expecting that part to already have as many elements as we've already looped. So it's not in the parser, right? It was in the data tree in the GUI that bug was. We saw that bug. Gotta fix that. There, dude, man. It's a rare rhymey streamy. So I didn't stream for a year and a half, and then I streamed 2 days ago, and now it's today, and I'm trying out a schedule where it's Monday, Wednesday, Friday evenings, my time, and or weekends during the day of my time. We'll see how it goes. But I wanted to get back to streaming because I learned from you guys. Maybe you learned something from me, and I think it's more fun to work on the stuff while I'm talking through it and maybe explain some of what I'm doing. So if you haven't been able to tell, I'm trying to parse JSON with my programmable parser. So I'm teaching it different elements of JSON. So like the white space before, and then here's an object. It didn't get all the way through because we got errors we're working on, but here's the opening brace of an object. And then we have it parsed 3 elements so far. So we have the first name, the last name, and then we have the is alive, and it parsed the value of the first one as a string. Oh, it shouldn't have done that one. That's another bug. I think that's if it's in the alt. In the alt, it tried to parse an object and it failed. It should have removed it. Okay, that's another thing. I think that's actually similar to the other bug. So really, it's do not populate parts that failed in an alt. I'll explain in a sec. So this is showing object and string, and it parsed string successfully, but it left in the fact that it tried to parse it as an object first. That's because the syntax is value, which is an alternate of, it could be an object, string, list, or number. So it tried to parse it as an object, failed, moved on to string, succeeded, and that the success of parsing it as an alt completed that statement. It should have deleted the attempt to parse it as an object, but obviously it didn't. It left it in the data tree. So, dude, man, I thought you meant rhymey because that's what some people call me. Either way, it's all good. Yeah, so we have some bugs. So that error is not really an error. It's just it said, hey, is it an object? No. Is it a string? Yes. So we are failing here because it actually tried all 4 and gave up. And it mostly gave up because it didn't know what a number was. and then it stopped, I guess. Oh no, I'm not. That's not right. It tried list, it tried number, and failed. Oh, it means that there's also Boolean, right? So that, by the way, it shouldn't print these errors either. That's another to-do list item I have here. Don't pass an error message along to the client if it's emitted while parsing an alternate. Yeah, this alternate syntax I added kind of recently, and I haven't really tested because it really didn't have any place within the other format I was working on, which was GIF. If I go there now and show you, can't find it there, so I'm just going to type it. There's no alternates in here anywhere. I never used that syntax here. I only added it because I was thinking ahead, like I'm going to need that later, and I don't really have a whole lot of tests around it. So now that we're trying to use it, and we're finding all these fun errors and bugs associated with it. So yeah, value, if we wanted to parse that, I need to be able to have a bool, right? True or false. Ugh. While I'm at it, I should look here and see what are the things that can be, so it's object array, string number, true, false. Oh, null. Forgot null. Yeah, okay, so let's get it past that point. So to do that, let's define what bool is. That's really an alternate, right? We're gonna have some optional space before. Do I want to do that for every value? I have it here. So it should have already eaten the white space. What about object? Open brace. So open brace again. I do have that there. I sort of need to decide on where I'm usually going to eat white space. It looks like I'm always eating, it looks like I'm eating it before object. So open brace really doesn't need to have this at all, does it? And I don't think close brace needs, oh no, close brace needs it, so does comma. Well, hold on. I can eat the white space in the loop and then fix it that way, right? Yeah, why don't I do it? Wouldn't that be the smartest, is to just eat it before name value? And then eat it before and after name value, then I don't need that there. I probably want to do that then, because that's easiest to understand, right? Just assume that white space has been stripped before you enter, but the internal white space we want to, that's our responsibility to eat, right? So then close brace, I don't need it because we've already eaten it there. Yeah, I don't need that there then. And I don't need it on comma. So only internal white space should we care about. That makes more sense to me. Only internal white space. Yeah, I don't really need to see it. It just clutters my data display here. They put comma at outside element. Why did it do that? Because it is outside. Shoot. I could just hide the comma. Then it won't clutter. Yeah, so then we have open brace, then we expect a close brace, but we don't see it because we didn't actually successfully parse that value. Yeah, okay. So let me get the Boolean in there. So bool is an alt, right? It's either a true or a false. Let me make one general purpose like expect literal. Ooh. Or expect literal false. And we'll name that true value. Or true. I can't call it true because true is a keyword, but I can maybe put an underscore after it. And then let's define what expect literal means. And then I can say for I equals 0, I is less than length of literal, I plus equal. I have a very rough for loop syntax. Like I don't have plus plus. It would be nice to have ranges, but I don't have that yet. So this is the best I can do for now. So I would say like what was it, UTF state char C. Then if C is not equal to literal. Can I index strings? I can't remember if I can index strings or not. Let's see if I can. I actually don't remember if I can or not. The other problem is, can I cast to string? Or really, I want to cast that to a unsigned integer. I don't know if I can do that. Let's see if I can do it. Then error. I have to say something. I think I have to say something. Actually, let's see if I can get away with not saying anything. Hold on. I think I have a syntax error. That's why I didn't like it. Error parsing, identify true unexpected on 101. Oh, because my syntax, the arguments go after the name, if it exists. Semi-expected on 110. Wait, what? On column 18. Oh, semicolon unexpected, right? Yeah, so it actually expects a string of some kind, or some kind of value. Put anything I want, right? How about I just say expected plus literal I. And we'll actually be nice and put quotes around it. Got C. Can I convert it to a string? Let's see if I can. Maybe it's time to actually add those type conversions if I don't already have them. Literal true is not indexable on 109. Okay, well, yep, that answers that. A string is not indexable. I might have to actually add that to the language, or really I need to add a built-in for that, right? Or I have another way to do this. If I just go with the built-in type S, I don't want to have to do that. Why don't I make it indexable? That's the easiest way to do it. So let's make it indexable. So I would start with a unit test. We look for indexable. Here's where we do indexables. So we can index vectors and maps, but we can't index strings, and it's in two places. Because one is where it's mutable and the other one's where it's immutable. If it's mutable, that's fine, not indexable. If it's immutable, we should allow it to be indexed, right? So here's where I would add the code. So it's within context of a reference. So I have to look for, see, where do I have reference tests? I have them here. Here are my reference tests. So we're going to add a new test, right? And why add from scratch when you can copy from someone else? Copy from someone else. So we're going to call this test reference string index. Index string. So let's see, what are we going to do? X equals ABC, return X1. Simplest thing we can do, right? It doesn't matter what the bytes are, ingest it. We should get what? I guess a string. No, let's say we always get 8 bits by indexing it. So whatever B is, unsigned integer. Oh, didn't I have that on my homepage? I do. Look at that. Little b is 2. Is the value of foo. Not an error. There's our unit tests. So we're basically claiming in our test that when you index a string value, you get back an unsigned integer, which is the ASCII code of, or that 8 bits, because the strings in my language are ASCII strings, or they're not UTF-8. They're simpler, the old simple way, 8-bit character strings. So this is going to hopefully fail with the exact same message. Yeah, X ABC is not indexable. So now we have our test, and now I can add the code to fix it. So let's bookmark it so I don't lose my place. And then I lost my place in the other thing. Here it was, right? Let's before I lose it again, let's toggle this one. Okay, here's where we're going to add the code. I try to do TDD. I don't always succeed though. So to make it work, we need to allow strings S to be indexable. And then where's the index? Oh, is it index? Right. So we have to evaluate the index expression, just like we would do for a vector, right? And then that gives us back an I size. So it needs to be. Do we want? So I have this range check thingy because I wanted to allow negative indices to count from the right. Do I want it to be that sophisticated or just do the minimum? I'm thinking about just do the minimum. So like I would it would get an error if it's less than 0 or greater than or equal to the length of the string, right? So actually, to do it properly, I should do the minimum amount of work, right? So let's just blindly use the index, and then we'll make a test that checks for going out of range. So art or value equals data value unsigned integer, and that is type of S is string, right? So just raw index as U64. Do I even need that? I probably do. Let's see. Then ultimately I got to do share. Oh, to wrap it into the enum. Okay, yeah, it doesn't like me indexing by I size. So here's where we're just going to do the minimum and just do an as. Cannot be indexed. Oh, I had to do U size? How do we do? How do we index a string again? It's like, I guess I have to do as bytes, then index it. Yeah, as U64. There we go. Oh, I think we got too many lines. Too many lines. So I usually save fixing that till later, and what I do is I just allow it, but then I leave a note to myself to do needs refactoring, because I'm not really good enough to write the code right the first time and be refactored. Wait. Be expressed infallibly. Okay, do what it says. There. Yes, and this is why we're going to need to we want to have a test against this, but right now we're going to ignore it. Where do I put that then? It's probably going to tell me it doesn't allow it on an expression. So do I put it in front of that? Yes. Okay. So now we go see if our test passes. And then I'm going to make another test that actually breaks it. So run the test. Hey, look, it works now. So make sure I didn't break anything else. Run all my tests. Run, 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 run. I like that I can run all 600 whatever tests in under a second. Okay, so I already know that we can break this. So let's do another test. Reference index string negative index. Why don't we just call it negative string index? And then we just put a -1 and we will watch it crash now and laugh at ourselves. Ah, it failed. Look at the index is huge because we blindly cast away the sign. All right, so we got not only we got an incredibly huge index, but it's also out of bounds. So go back to the other place. So yeah, we want to. Oh well, hold on. Before that, we don't expect it to actually work. We expect there to be an error, right? And I might as well expect nil, because it should have failed at the return, so the overall value won't have a value, right? Still fails because it panics. Let's have it fail properly. So then say if index is less than 0, return error format. Index. What do we print if it's not found? I guess I just return nil. What do I do in index range check? My little click and go isn't working, probably because I broke it. Click and go here. Aha. Why write it when I can simply copy paste here? The length is the number of characters, so that's S as bytes length, right? Needless column to ask. Oh, length is the number of bytes? All right. Fair enough. Okay, so now that should make this test pass, and we should see the correct error message. No, it didn't work. Oh, did I not mark it as an error? Foo error is not true? Wait, what happened? It should have printed an error. That's what this is supposed to do. What? Oh, did I run the wrong test? I might have run the wrong test. Okay, we have the index -1 out of range. Oh, I messed up. I hit the wrong test. Ah, shoot. This actually goes down here, and this goes up here. Right? So for this test, this should be not an error, and we get 62 hex out of it. Pass. Okay, and this test passes because we should get index -1 out of range for x -1. Perfect. That's what I wanted to see. Okay, so then we want another test for when we go out of range positive. So 3, right? That should also fail. So this is string index out of range, out of bounds, or beyond end. So this should panic in a different way. The scroll wheel is not working for me right now. Yeah, there we go. Panicked. Length is 3, but index is 3 on line 222. That's here. I guess we can just add to this, right? Or index greater than or equal to s lane. I need to cast one of them. If it passes through this one, then it's safe to do as usize, right? I'm going to assume that that's safe. Cool. So passes. Index 3 is out of range for x3. Length is 3. Perfect. Ready to run all my tests, and then we can index strings now. So going back to this should work now, right? Except for I don't know if I have cast UI and S, so we'll have to see if I did that or not. Actually, I don't need to cast it anymore because I chose to make that return an unsigned integer. This should upcast to a string for me. Okay, how far did it get? Ooh, it got further. Ooh, look at that. The value is true. These errors, again, are things on my to-do list. It should strip these out, so we should see value bool true. And the true is TRUE. Awesome. It got past that, and it went to 3, which is an emoji. So the value is a string with... I still have some of these space befores. Let's clean that out. Uh-oh. It's not allowing me to click there anymore. So annoying. Like, I can't click on the bottom anymore. What is that? Some kind of, like, bug in the virtual machine. Anyway. this right here, right? I don't need this. I don't these that was okay while we were developing it, but it's just clutter now. You know, how do I there we go. That tab. Okay. Cool. So we have name, colon, value. It's as a string, quote, the character. Yeah, see the like the not quote shouldn't be there. You know what's interesting is it says the format is not quote. That's not correct either. I think that's another consequence of the alt syntax. It assigned the format of the overall vector as not quote, even though it was a mix. And actually, this one, it should not have, it should have removed that. Anyway, the emoji is one character like it should be, with a different encoding here. Okay, cool. So what are we on next then? The value, it doesn't like numbers. All right, so we're doing numbers next, I guess. Almost time to reboot. Because my, see where the cursor changes from that to that? It's like there's a dark zone where I can't click there. There's like a zone of can't clickness, right? Right, here's the corner of it. Okay, here's another there's like something there that I can't click. I can't click in this area for some reason. Why would that be? Is there just like something in the way? I just can't click there. This doesn't want me to click. Hey there, Mr. Sir. I've been rated by CM Griffing. Hey, see that chat above my head? Where might you have seen chat overlay like that? Well, it came from Mr. Sir himself. We're using Stream Parrot. Still works. Yeah, I'm working on a programmable parser, and today I decided I would teach it JSON. So we're teaching it all the elements of what a JSON file can have. So we have objects, which are names and values. Names are strings. Values are object, string, list, number, bool, or null. And this is kind of it's written in a language that I invented for my programmable parser. So the parser program that I wrote has a compiler built in. It compiles this format file, and then it uses that compiled format file to parse the data file that you give it. So that's what I've been doing here. So what it's working on is this sample JSON, which I got off of Wikipedia, right? And I chose JSON today because I figure it's a lot easier for people who have no idea what I'm doing to at least understand a little bit. So like if I'm writing a program that can, I can teach it to parse JSON. The way I do it is start with JSON and, whoops, you feed it into my program and it looks like a bunch of bytes at first, but then it starts to pick apart what those bytes are. So it says, oh, there's an open brace. And it got 5 of the elements of that first object before it stopped. Right now it's stopping because it doesn't know how to parse this age here, this number, because we haven't taught it the number syntax yet. In fact, it gets all the way down here and it should say something like unknown format number, because I haven't defined that yet. And that's where it stops. So, yeah, but right now I'm encountering a problem with my VM where I can't click down here. So I think I'm just going to tell it to reboot. Fortunately, rebooting is fairly quick. Yeah, where is Twitch? Is TwitchCon in San Diego again? Anybody know? Not a con fan? I don't actually go into TwitchCon. I just drink with people at the bars nearby. Yep, San Diego. Yeah, I'll have to try to remember to put it on my calendar this time and not forget about it until like the week after. And like, oh, when was TwitchCon? Oh shoot, I think I just missed it. See how fast that reboot was? We're good. All right, so Let me know if you have any questions. But yeah, programmable parser. We're teaching it, and it can parse strings and booleans, but not numbers yet. So let's do numbers. We started out today actually. I didn't jump straight to like characters. I actually took the time to define what a UTF-8 character is, based on, if I can bring this back up again, restore, and I go to UTF-8. Go to the Wikipedia article for UTF-8. It tells you how to parse a UTF-8. So I translated that directly into my parser, my parser's format language. So you can kind of see, if I flip back and forth, that it's very similar. There's like 4 alternatives based off of what the first 4 bits are. And you can kind of, if you look at this long enough, you kind of get what I'm doing. See how there's like the fixed bits here, and then there's the ones with the letters. Those are the variables. So the variables are all these parts, and the fixed parts are all these ones that we're ignoring, or we look at the first 4, and this plus means look ahead 4 bits and then rewind back. So we end up having to ignore them again, the first bits. And we also ignore the 1 zeros that are in the bytes 2 through 4. But other than that, we're parsing bits out of each field and combining them by shifting them and adding them. So probably you figured out by now that unsigned integer, and then there's a name, and then if there's a colon and a number after it, that's the number of bits. So encoding part 1 is 4 bits. We're talking about this W's there. And then ignore 2 bits. That's what the minus in front means. Ignore 2 bits, and then parse 6 more bits, which is the XXXXYY. And then the third part, and then we shift them and add them together. So I started with that because people who are watching the beginning of the stream, I think maybe that helped both me and viewers figure out what I was doing before moving on to something more complicated like JSON. Oh yeah, that's right. TwitchCon was at Vegas that one time. I prefer it being in San Diego because, I don't know, I like San Diego better than Vegas. It said it parses bytes. How would it parse Unicode strings? By forming larger, higher order composites of this UTF-8 character. So this tells it how to parse one UTF-8 character. And then I have another format file that, let's see, for string here, it has a loop in which it's collecting all the characters that are not quotes, and then if it is a quote, it breaks out and parses as a quote, and then not quote is, hey, it's a character. Expect it to be a quote, or not, expect it to not be a quote. If it's a quote, there's an error. So this is invoking this. See how that works? Like it's type and then name. So they can build on each other, and you can have loops so that the string is formed by looping through and collecting UTF-8 characters until you see the end quote. Yeah, exactly. So there's a lot of building blocks here that build off of each other. So a string isn't reused when we do name value because the name is a string, and also the value can be a string, right? Some things that are unique to my language, I've been going through this before, but I'll talk about it again, is this alt construct. So I envision this as like exactly what you might think for JSON. When you have a value in JSON, it says here that a value can either be an object, array, string, number, true, false, or null, right? So I translate that almost exactly as the original specification to be object, string, list, number, bool, or null. And the way it works is that it goes from top to bottom until one of them succeeds. And it's supposed to ignore anything that failed and just move on. But right now I do have a bug in the code where when it ends up displaying it here, it will show the ones that it failed to parse it as. Where is that? I guess it's under value. See, like this value, which is a string, it first tried to parse it as an object, and then it failed, and then it tried again as a string. It should have deleted this red line here. If I hover over it, it's gray, but you see how it's red there? It should have dropped it off of the GUI, but it didn't. And so that's a bug. But other than that, That's what alt does. And the else is if it's none of the above, we have an opportunity to do something. In this case, it's an error because it's got to be one of those. Other places I use the else for an alt as a control instruction. So like this was the way I decided to keep parsing characters of the string until it is a quote. Because if it's not a quote, we break out and then parse it as a quote. So kind of implied by this is if it's parsing it as an object and it fails, it rewinds back to the beginning and then tries again as a string. And if it gets a little bit in and then says, oh, it's not a string, it again rewinds back, tries it as a list, etc. That's how we end up parsing this character twice. If it is a quote at the end, it parses it twice. It first parses it inside of not quote as a character and says, oops, it's a quote. And then it backs up because the alternate failed. It goes to the else because there's no other alternates, breaks out, and then it parses it as a quote. So the GUI is supposed to like not show the where it backs up, but unfortunately it does still. We'll fix that. Let's teach it what a number is. Where to put it? How about right here? Number. I think we're going to end up with a loop. And we'll have like, I don't know what to call it, sum. And we're going to, at the end, we're going to return that sum as the parsing of the number, right? In the loop, I think what we want to do is we're going to have an alternate with an else. Because we're expecting a digit. We can just call it digit, right? If it's not a digit, we want to break out. So if it is a digit, we want sum equals sum times 10 plus digit. And then we just have to say what a digit is. So digit, we're doing UTF-8 characters, right? So we get a character if the character is greater than or equal to, and now here's where I look at my handy, because I can't compare an integer with a string character directly, so I just look at ASCII. So it's between 0 and 9, right? So 30 hex and 39 hex. And C is less than or equal to 39. Else, we're going to say digit expected. Another thing I have on my list of things to fix is when we hit an error, this string is meant to go all the way up to the GUI, but we should not print it if the error happens while parsing an alternate. It's supposed to back all the way out and then pretend it didn't happen. Right now it prints it even if it backs up, so we have to fix that. Almost like a sum type. Yep. So if it is that, then I guess we're just returning C minus 30, right? So let's see if I did, there shouldn't be spaces here. I don't know why there is. Let's see if that fixed it. Nope. It completely broke. What did I do wrong? Oh, it thought, okay, it parsed that T as a number. That's not good. It thought T was a it thought T was a number. Oops. Yeah, that's not good. Oh, I see. Yeah. So we need to make sure that we actually make an error if the first digit is not a number. So I guess what we do is first true, and then first equals false. Error. not a number. First is maybe not the best name for that. Ooh. Assign unexpected on line 109, or 105, 105, 105, right here. Oh, right, I can't do that. Shoot. I need to move that here. That's another rule I have in my syntax, that alternates can only be part specifications. They can't be control statements or local variable. They can't be assignments, any of that. They have to be part statements like that. Okay, it got much further. All right, so we got numbers. Look at that. The value is 27. It even parsed it correctly. Woo! All right. And then it got to 5, which is it even handles nested objects. Look at that. It found the end brace and everything. I am impressed. It got that name was a little bit wider. The value. Oh, you know what? We didn't propagate the actual name as the value of name. Let me fix that because that's annoying. When we parse name, where's string? When we parse the string, we need to return it. Oh, that's tricky because I have to take each character and then assemble them back together, don't I? Okay, I'll do that later. Because I don't know if I have a built-in typecast integer back to string, and I especially don't handle UTF-8 yet in the parser itself, so the native string type probably won't work so well. So let's add this, add type casting integer back to string as a character. Or maybe a built-in to turn an integer into a character. Maybe even support UTF-8. Because that wouldn't be too hard. You just take the integer and you interpret it as a single code point. So it could be greater than 255, and it doesn't have to be a single byte. But for now, we just won't return anything. So that means this name is going to be blank. We have to actually look and see its street address. And then here for the value, since it's also a string, we don't see the string here. But back on this other one, so this one we should have been able to print true, but we didn't. Why not? Oh, because I don't have a return statement for that? Let's see. So for value, oh yeah. We're not returning the value actually parsed out. Okay, I also don't have a way of propagating the alternate that succeeded back out. Okay, that's going to be a problem. Unless I name them all the same thing. Let's see if that works. This might work. If we name them all value and then we just say return value, this actually might work. I don't remember if I allowed that though. That's optimally what I want, right? I want one of them to be the value and I want to return it. That worked. I don't think it did. I keep forgetting to, when I change it and hit save, to clear the log first. Unable to parse object, unable to parse element. Wait, what? One format null. Oh. 37? Yeah, see, all the alternate errors are crowding things out there. Hey, Anakin, Luke, how are you doing? I messed up somewhere here because it can't even get that first value. It thinks it's an object. Oh, I know what I did wrong. Okay, that's another bug then. When it fails, it's supposed to forget that it tried to parse it, and so it should have deleted the variable called value, but it didn't. So then when it gets to string, it's like, oh, wait, I already have something called value and it's messed up. So yeah, I can't do that right now. I'll have to fix that later. Another to do. Parts inside an alt should, I guess, should share the same name. No, not share the, should be able to have the same name, since only one will actually parse correctly. We stop after the first success. Yeah, right now they can't have the same name because we don't remove the one that failed. I'm doing good. Is it possible that you switch at one point back to C++? Probably not, because that's what I do for my job, and I want my hobby to be something different than what I do at work. And I don't get to do Rust at work, so it actually fits really well that I get to play around with a language that I like during my off time, and that I don't, I can kind of keep it separate from work. So, would there ever be a reason that I would want to do fun stuff in C++? Maybe like if I wanted to learn some of the new stuff added to C++, I might stream some of that. So yeah, I think it would probably be like if I was learning something new in C++. Okay, cool. So we got all the way down now. We fixed it. We got it all the way down to where it doesn't know how to parse this thing. It didn't parse as any of what we have so far. So it's not a bool, it's not a number, it doesn't know how to parse list yet. That's what it should have succeeded at. It didn't get a string or an object, so it failed in all that. So it doesn't know what a list is. So we need to teach it what a list is now. List is going to be very similar to object, right? So maybe we can just start with object and then replace it with, or make a copy and replace it with list. And this is like opening bracket, open bracket, close bracket, right? And then we have some white space, and then we don't have a name value, we just have a value, right? Just a value. And then we either have a comma or we break out of the loop, right? Okay, and then open close bracket is like open close brace. It's except for the character is different, right? So what is it for, what's the ASCII code? 5B for open. I'm going to hazard a guess that it's 5B and 5D. Let's see if that just works. All right, so actually I should be just able to click on that. See that that's the list there. Oh, it worked. Hey there, 3D Code Warrior. All right. Ignoring the red noise in here, it sees the list, and it sees the list has two things in there, and there are two objects. One of the objects has two elements in there, the name, the type and the number, and the widening this a little bit. Widening that, we can see there's the type, and then home, number, and then the number string. Working. Yeah, see, it parsed the open and closed bracket correctly. Here's the other object. It's got two elements also, type office, and then the phone number. Sweet. So it got further. It got all the way down. Ooh. So it actually got all the way to the null, which we haven't done yet. All right, cool. So we're almost done, actually. When I finish this, I think I'm going to go back and start to clean up some of the bugs that I found. We don't need to see that. So I don't have null. Null is like true, like the bool, right? So null is just an expect literal null. Yep. Value is, wait, what? Didn't parse the null correctly. See why. So let me reopen the file. Element. I need to fix all this because it's just noise at this point. It got the name spouse, it got the colon after that, and then it kind of choked on, it thought it was a bool of some kind, but then it failed. It didn't even try null. Why didn't it try null? It should have failed on bool and, oh, because I don't have an else here. Else, error, bool. Is it called bool or boolean? Actually, it's neither. They actually have distinct values, true, false, null. So maybe I should do the same. So like instead of that, I just move all of these directly into value. Like this. Yeah, why don't I just do that? That's easiest. Either true, false, or null. Although, I'm wondering, is it going to be okay with me naming them that? Let's see. Oh, it passed. Nice. Yay! It knows JSON. So there we go. Now we have the parser parsing JSON. We have all the overall object. We have each element of that outer object individually parsed. And in the case of like a nested one like this one, we can see that its name is separate from the value, and the value is a list. Ignoring the red noise, because it's supposed to remove those. The list has two values in it, which are both objects, and each object has two elements in it, and each element has its own name and value. Right? Sweet. All right. We're done. It knows JSON. It knows Kung Fu. Yeah, exactly. So the cool thing about this now is my parser has the ability, if you click anywhere, it tells you where you are in the tree. So if I click on the S in Smith, it's like, oh, that's the encoding for the first character of the string of the value of the second element of the object, right? If you could just click anywhere and walk up the chain. So I click on, let's click on the null. It says, oh, that's the encoding of the second character of the null in the value of the 8th element of the object. So it totally does the reverse thing. Oh, here's another thing you can do. I can type in null, and it shows me all the places where there's a null. Or I can type in that number that we had up there, 27, right? 27, and it finds the 27. So searching works by searching the parsed values, not the originals. So because I don't have the name assembly done yet, it won't find address, even though address it should have found as the overall value of this string here, this name address, right? It should print the value as the string address, but I don't have that done yet, so the search won't find it. But it does find numbers, and it'll find the null that I made there. What else would it should be able to find, like all the commas, no, all the colons. Yeah, so there's 17 colons in the file because I did not ignore them. I left them in. Okay, now I think I want to work on getting rid of the noise here. So it shouldn't print out any errors because technically all these errors happened in alternate paths that it should have ignored because it found a different path through parsing. Maybe let's work on that next. Oh, first I get to mark off that this is done, and we'll make another one for JSON parser. Actually, give it its own timestamp for XML parser. We'll do that later, and then I get to say that that is done. That is a big fat to-do list. Most of these are done though. There are a few in here that aren't done, like I don't have a way to navigate through errors yet. I haven't done namespaces yet, but like if you go through there, I've either done them all or I've marked that I decided not to do it. Yeah, I was going to do a JPEG parser. I'm kind of steering away from complicated formats because I think they're too esoteric. While I'm streaming, people will probably not know what the hell I'm doing. So I think I'm going to stick to like easy to understand formats like JSON. Look at that. But yeah, let's, these are some of the things we found today that are problems. So let's see if we can suppress the error messages emitted while parsing an alternate. I think we should start with the unit test. So I need to find a unit test that actually collects error messages, and we'll use that and make a copy of it. And then our invariant will be, we should collect no error messages on an alternate. So I think the way I did that was I used a channel. So let me see where I used a channel in a test, and I'll probably find, oh, here we go. That's complicated. Let's try to find a simpler one. Okay, so it looks like I have a helper function in my tests called ingest and receive errors. So we can see where all that's used. Okay, here we go. So here's where we got a receiver and we got the message back out and verified that the message is a certain thing. So we can kind of just take this test and kind of steal it. I think this should belong in my tests that are around the alternates. So that would be alt. Here we go. So I got just 2 tests for alternates. So I have a test for an error in an else. Should not be an error in X, but it should be an error in foo. That's correct. Like that was the main part. Those are the main assertions there. I guess also that X gets defined but not Y because an error should skip Y. So there's no Y, but we got past X, so that should be okay. Yeah. Cool. I understand that test. So let's make another one. So test error callback suppressed inside alt. All right, so the test is going to be, let's keep it simple. Let's just say have an alt, and we'll have like a bar that does, that just errors, right? The simplest as I can think of. Should not see this. All right, so what do we assert here? Really, the only thing I care about is that we don't get an error. So I don't really care if foo had an error or not. It shouldn't. It should be suppressed. So assert that there's no error on foo. Don't care about the bits. Right. So we should not get any message. So really, I could just make an assertion here that when we try to receive from the receiver, it should be an error. Right? There should not be any error messages. So when I run this, it should fail. All right. It failed. And because I have set up logger, it should log it as should not see this somewhere. Where is it? I don't see it. I thought the logger would have logged it. Hmm. This should have. Oh, did this suppress them maybe? Oh yeah, we have a with error callback that just drops it. Okay, so that's why. Normally in my tests, my error callback does a print. Where would I see that? On a normal test. Like what's a normal test that I've done before? Here. Yes. So here. Oh, is the default? Does it have a default error handler? I don't see it actually. Wait, then how is it being printed in other tests then? Okay, now I'm confused. We should be able to see that with error, right? A lot of them. Here. Oh, so my tests don't include this. So how am I seeing them normally then? Oh, here it is. That's what it is. So it should have been logged. Why didn't it not get logged? Hi, RA3H. Trying to understand right now why the error message in my test here not get logged when I ran the test. Set up the logger. Set up logger should simple logger, so it should show up in the output here. But it never did. Unless it's here somewhere and my eyes are just not seeing it. You know, I could just step through this code and find out why. Did you watch Squid Game? No, I did not watch Squid Game. See. So what I'm gonna do, I'm gonna toggle that bookmark. I'm gonna delete these other bookmarks. The Netflix series. I think I knew that. I just haven't seen it. Yeah, what does that have to do with what I'm doing though? Are you trying to distract me? Well, let's close all files, but this... Not at all. Yeah, trying to focus. Focus. So I'm sorry if I can't chat about different things. Hard for me to like chat about something like Squid Game and then try to fix my code at the same time. If you have a question about the code I'm doing, I'd gladly pause the work I'm doing and explain it. But if I were to start talking about Squid Game, then I'm no longer coding. To see how that it's no longer the stream doesn't have anything to do with coding anymore. So, well, I kind of look like a person. Like I see. Okay, I see what you're getting at. Yep, not me though. But I can understand how I might look like someone from that. Let's see. Where was I looking? The the error statement should have gone through the error handler, which should have logged something. So I want to see. I want to set a breakpoint there and see what's going on. So that's not in the tests. It's in context statement. There should be a execute error statement. Here it is. right, this should have done that, and so we should have seen it. Oh, this is why. If we have an error handler, we delegate to that and we do not log it. That's why. Okay, so then if I really want to see it, then I would actually need to put it in the error handler right here, right? I just have to do that. And then I need to import what error means. Sometimes it doesn't get it by default, so I have to go here and tell, yeah, we want to use log error. Now it will be fine with that. And then when I go back to my tests and run it, now I should see the error message saying you should not see this. Where is it? Oh, there it is. Should not see this. Oh, no problem, Harry. I just didn't know what the question was leading to. Should not see this. Okay, cool. So that's what I expected it to fail in that way. So instead of seeing it, since we're in the context of an alternate block, we want to suppress it. So we not only do we not want to see it on the log, we also don't want to receive it back from the channel that we made in receive errors. So we made this channel, we gave the channel to the error callback so that we gave the sender end of the channel to the error callback so that it can send the message so that our test can go try to receive it. We get an error if we couldn't receive anything. That's what we expect. Because we did receive something, it failed our assertion. We need to make it pass by not actually, this should not make it out. So that means we have to teach our code to like suppress errors if we're in an alternate syntax. Now I have to think about how to do that. It was here, right? So it's on error. Call hierarchy. Okay, we call it from a bunch of places. So this is all in the implementation of context. So maybe the best way to do it is context should have some state to track whether or not we're inside of an alternate. I thought I already had something like that, but it doesn't look like I do. See, this context structure holds on to the state of things as our parser is parsing. So it remembers where all the format definitions are. That's what ingestion is. It's probably not a very good name. It remembers whether we're parsing little endian or big endian. It knows the offset of the input in bits, so that if the offset function is called inside of the format description, that we'll be able to return it. Same thing for remaining, the number of remaining bits. Boundary is how far we're allowed to parse before we violate a boundary and we generate an error. That's if we're in a bounded region. Like you can only parse up to 32 bits, and if you need more, then sorry. This is the current format we're parsing, the current statement, and the span, so that if we have an error, we actually print that. And actually, when we execute error statement, we should see that being used. Yeah, see, it uses the current statement span that we were just looking at to build the message that it printed. We remember the names of the local variables so that we can remove them at the end, and the path of the current thing we're parsing, and the iteration context. So I think I need to add to this something that says whether or not we're in the middle of an alternate. Because if we are, we do not want to, we want to suppress error callbacks. I think we'll just add it here as a Boolean. So where to add it? Problem is I never went back and sorted all of these fields alphabetically. They start out sorted if you start from here, but then we go back to B here, and ingestion is probably because this was named something different that was before B, and I renamed it. So maybe I inserted among here alphabetically. It would be like right here in alt. Cool. True if what? The words are difficult. I need to describe it in a way that when I come back to this 6 months later, I'll read it and know exactly what this field means. Overall, what does context mean? Maybe I'll just see. Well, that's interesting. So I don't have a comment for context. Forgot to write that. Anyway, maybe the component. This is the portion of the composition being okay. So I can use some of these terms. True if the if this context is currently within. I'm going to borrow from terminology from where I define what an alt is. Where do I do that? AST maybe? Statement? Oh. No, it would be here. Statement. Here somewhere. Alt. Alternative parsing statements to attempt one after another until success. Right, rewind. Exactly. So true if this context is currently within an alternate. Need to bookmark this better. You have to keep finding it. Alternative parsing statements. Do a sequence of parsing statements. Okay. True if this context is currently within a block of alternative parsing statements. Like I want to say like either directly or indirectly. Like as in like if we go up the ancestor chain in the component hierarchy, we'll hit a component that was an alternative. A component that was one of many alternatives. True if this context is currently within a block. Actually, then the way I kind of want to say this, true if the part, the portion, true if the component or any of its ancestors is an alternative. An alternative is one of the set. Words are difficult. True if the component or any of its ancestors is an alternative part. This determines whether or not the component, whether or not errors encountered while parsing the component are emitted to the user's error callback. I guess I can just say the error callback. It's probably better. True if the component or any of its ancestors is an alternative part. This determines whether or not errors encountered while parsing the component are emitted to the error callback. Okay, good. So now that I've introduced that new field of context, all of the 6 errors here kind of identify what need to be added to the code to complement the addition of that field. So one, it's going to say things like, well, you didn't initialize it, so let's initialize it. In alt. So if it's already ingested, we can't get it from the composite, so I think we need to actually pass it in. Right? We don't have enough knowledge to know whether or not we're inside of an alternate. So we pass it on to the caller, has to tell us. Next error, new with part. Same thing, right? So again, we need to know in alt so that we can set it here. Next error, new with uningested composite. I think it's the same thing. We don't know. Right? Let me see the call hierarchy of that. If the function call or if it's the top level, right? Even then, like, this can be an internal component. Yeah, I think this is just gonna be passed through, so alt. All right, so we added an argument in a bunch of places. So evaluate function. Okay, so here we're within a current context, so I can just, what I can do is I can just say self.inAlt. Because if it's already set in the parent, it'll be set on the child. Next error. Execute parse statements within context, so it's the same thing. So self.inAlt, right? All right, and then the next one, this is the top level ingest, right? Oh no, wait, this might not be. So we need to maybe add it to this one? Yeah, let's add it to this one in alt. And then this becomes, it gets broken out, right? Where do I do that? Component with args. Yeah, right here. Component with args dot in alt. Right, we're generating a lot more. Right, because we use data component with args in a lot of places. Why not use an observer? It's not very DRI. I'm not sure what you mean by an observer, I guess. So the reason we're doing all this is that there kind of already is an observer for errors. We just need to know whether or not to call it. So when we're executing an error statement, for example, and we call this on error. Actually, there's a lot of places where on error could be called. There's a thing where if we have an error handler, we call it, right? Thing is, I don't want to always do that. I want to suppress that if we're inside of an alt syntax. So, for an example, that JSON that we were doing here, let's say we're trying to figure out if a value is an object, a string, a list, etc. Let's say it's a list, right? So it tries to parse it as an object and fails because it doesn't start with a curly brace. So it'll generate an error because the first thing that object does way up here is it says an object begins with an open brace, and an open brace, it's an error if it's not an open brace. So when this error statement is executed, if it was in the context of a document, sure, we want that error to go all the way back out to the UI and say, call the callback, because we expected it an object in that context. It's not an alternate. If you don't start with a curly brace, it's definitely an error. But if it's an object that's nested, and we don't know if it's an object, a string, a list, this will generate an error internally because it won't be an object. But the alternate syntax says you try one, and if it fails, you rewind, pretend it didn't happen, and try the next one, etc. until one succeeds. And if none of them succeed, you go into the else and there. So this definitely we would want to omit a callback for. But any of these errors we want to suppress. So the way I'm thinking about doing it is in the parsing context, we remember every time we enter an alt, we'll set the in alt to true. And every time we go to the else or we escape the alt, we'll restore it to what it was before. So we'll need to have, actually that means we'll need to have a memory of what it was before entering alt so that we can restore it when we come back out. Because you could have an alt inside an alt, right? Anyway, so when we set the in alt flag and this ends up generating an error, I want to see, oh, we're inside of an alt, so don't call the error callback. So when you say observer, to me, I think of this is the observer. So unless you mean a different kind of observer, I already have an observer. Right now the objective is to suppress the observer, to not observe the error if the error is something that it's an alternative. So it's an error means to back up and pretend that there wasn't an error. An observer that can handle state in concern. You can use it with a HOC like. Yeah, I don't know what HOC means. I'm sorry. Handle state in concern. So this context class is the state of the parsing. So I'm putting that flag in my state so that the objective is when I get down here, I'm going to have something like this. If self.inAlt, or basically if not, then do an error. So otherwise, like don't generate an error. Don't publish the error if we're inside an alternate syntax. Higher order component, okay. Server that can handle state, can use it with a higher order component. I'm sorry, I'm having trouble understanding what you're suggesting. So it's the way I have this designed, it's a little bit weird because the context is sort of like visiting a composition under construction. So this component is what we're parsing. We're kind of building it. And as we're building this composition, we're descending like in order traversal basically and building out this composition. So this context will kind of doesn't flow into the children of this, like the subcomponents, but a new version, a new copy of context will be created for every child component, so every subcomponent. And when we return back, we'll get back to the context of the parent all the way back up to the top. It's kind of like the context is kind of like temporary scaffolding while we're building a composition. So I'm not sure what you mean by higher order component, other than that maybe the data component is this is ultimately a composition because the component can have children which is a hash map which can have more components in it, so it can nest. There's actually many ways it can nest. You can have children by key, you can also have children by iteration, and actually those are the only two ways you can have child components. Yep. Function in a function? Yeah, the functions being run right here are all members of the context. That's why they're all borrowing from self. So maybe you mean like for a function that is, yeah, I'm not following. Sorry. I did make that change. I think I want to keep that because ultimately I was going to get to there. I just got there prematurely, but I think that's the code that I want, right? That's where I'm actually using that in-alt flag. I just need to make sure that I'm propagating that flag everywhere, and then the alt, executing an alt statement has some really special code we're going to need there because it's got to like remember what it used to be, set it to true, and then return it back to what it was when we're done. All right, so like every time we're going to assemble the arguments for parsing a component, we have to fill in what is the in-alt, right? So if we're building apart from the current context, I think we just propagate the self.inalt. think that's probably going to be in a lot of places. Okay, dereference. Dereference is not in an alternate syntax, so that's going to be false. All right. When we're ingesting in the test framework, it is not in an alt. Oh, maybe one thing you're pointing to is like when I have like new. Sometimes I have functions that build new things and return them. I could have one that builds it where in alt is like taken from somewhere else, so we don't have to pass it explicitly. But now I'm just speculating what you might have meant. So ingest. This is this is from the. I have like a bridge for Lua. So this is if we're doing what? The idea is to separate the concerns, and your observer will be a function that will alternate the function depending on the state that what you like, but still stay pure and go closer to a kind of declarative design. See, I understand the parts of your paragraph there. I know what it means to separate the concerns. I'm just trying to apply it to this specific code, and I'm not sure what concerns we're trying to separate. Because the in alt, it really is a state switch. It's like we're either inside of an alt somewhere or we're not. And like, I don't want to have to search up the composition ancestor chain to see, oh yeah, we're in an alt statement there. Like, I kind of want to carry it, like have it percolate down. So, and the concern of whether or not to return the error or not. Oh, do you mean like the on error should be decorated so that we would have, go back to that. Maybe what you're saying, maybe the problem isn't what you're saying, it's me trying to interpret, to correctly interpret what you're saying to get the gist of what you mean, right? How come I can't get back to that? I guess we'll just search for it. On error. Here. So maybe what you mean is this function, this on error function, which I'm storing inside of the what type is this? Why am I storing it there? Oh, because yeah, this is what the client provided as here are my callbacks and here are the formats to use. You're saying maybe this optional error callback, which is a boxed function, I could decorate that and just decorate it with something that does nothing when we're inside of an alt. So then I wouldn't need this check here. I would just always call the on error, and if we're inside of an alternate context, it would just do nothing. Maybe that's what you meant. It's almost the same. It would just be I wouldn't need to do this anymore. I would just have to decorate the on error when we enter an alt, and then undecorate it when we get out of the alt, right? Maybe that would be better because there are a lot of places where I'm having to propagate this flag. But instead of propagating it, if I just mutate the original here. One problem is that right now this is treated as immutable. No, it's mutable. So I can change it. Okay. Yeah. One reservation I have is that I might come back at this 6 months from now and wonder why I'm not seeing the error message displayed. I'm like, oh, I'm calling on error. How come I'm not seeing it? And then I'll have to remember, oh yeah, when we entered an alternate syntax, we actually like decorated the error handler with something that like suppressed the message being sent. Maybe with a different name, I could not forget that. This is literally what we want. This is the callback to invoke. It's just that we want to replace the callback with something that does nothing temporarily. Okay, actually, I'm liking this more and more. So let me try that. I'm going to look for in alt. So all this code is actually in version control, but I kept the version control bits out of the virtual machine. So I really can't use Git for this. So I have to do it the old fashioned way, which is just simply delete this. And then I just follow the errors. I'm like, yeah, this means we don't need this flag anymore. And just keep following this. Wait, why does it say it's missing? I just deleted it. Did I not save? Wait, what? I got rid of it. Missing. Is it saying that's missing here? No, I don't understand that error. Thought I got rid of that. Okay, this goes away. Yeah, so this whatever the error callback is, we call it, and that might do nothing. Such field in alt. Yep. It will be cleaner because really it's all centered around the alt statement now. Okay, yeah. Get rid of all this stuff that I added not too long ago. Right, this has an argument we don't want anymore. Where are we? Where's my cursor? One thing I like about Rust is that I get almost immediate feedback from the editor to tell me like where I need to go next. I don't really need to think about the flow. I could just like I'm following along all the consequences of getting rid of that field, right? And there we go. We backed out the change completely. Almost. A couple more. No false needed there. Just nice. How long have I been doing Rust? What's it been, like 4 or 5 years now? But not continuously. And I noticed that before Rust, I was doing C++, and I thought I knew a lot about C++ because I had been using it for like 15 years. But then I was proven wrong when I met people who knew it better than I did. So one thing that I learned around then is not to equate time of doing something or learning something to skill or knowledge level. Because you could be doing, I could have been doing Rust for 6 years and know very little of it just because I'm not learning very quickly. So the way I would answer it to give you the most knowledge is I've been trying to learn Rust for about 4 or 5 years, but I consider myself somewhere between a beginner and intermediate. Nowhere near an expert. I won't consider myself an expert until I look at John Hu's videos and understand what he means by pin. Like, I think that's the true test is you're not an expert in something until you can go to the acknowledged experts in the field and understand them at their level. And until then, you're going to be below them, right? And that's actually one way to learn is you go to someone who knows more than you and you try to get to their level. And it's okay if you never do. You just like, you can be happy however you get, how much you learn, but don't fool yourself into thinking that you've been doing something long enough that you're now an expert, because it may or may not be true. Jaron himself said you can't know everything about C++. Well, the other thing is C++ is constantly evolving. It's like every 2 or 3 years they come out with a new version of the standard with a whole bunch of new stuff in it. So even if you knew everything in C++ 11, well, now there's C++ 23 now. There's like 3 or 4 versions of the language. They've added a whole bunch of stuff. All right, so to fix this the better way, that Geronimo High Five has led me to is I will go to where we actually execute the alt statement. And then we're going to modify or decorate the error handler temporarily. So execute alt statement, right? Here we have alt statement. And in addition, so we record the original offset and remaining so that we can rewind to that after every failed attempt. And that is done here. So we break out by returning if executing the parse statement succeeds. So here's where we want to restore the callback. But before we do that, we want to remember the original error callback. Self dot suggestion dot there should be an ingestion, right? Hold on. Or let me look at all the places I referenced this. Yeah, so I should have I should do something like this. Oh, where was I? I was in statement. Yes, right there. All right, so best thing I think would be to just go into a block and do the stuff we need to do. So let the ingestion be, that should be ingesting a composition, and then actually we don't want the formats. We want some error callback is we want to borrow it mutably, which means we want it as mute because we're going to then reach the on error and take it. And I don't want to sum. We just want to get it, right? Actually, that's exactly what I want to take out. Well, that's what we're going to return, but we're going to replace it with something. Actually, that means I just want to replace it, right? And we're going to give it, what is the type again? It takes a bunch of junk. Okay. One thing I don't quite like about closures or function types is that you kind of have to see what the things are. So we don't really, actually, I don't care about any of this junk. Kind of want to remember what they were though, but we'll put the underscore in front so that we know what it would have been if we cared about using it. And then we're just doing nothing, right? What's wrong with this? Do I have to box it, right? Yes, I have to do dot boxed. We do this. Like box knew that? Yes. Okay, so we get the original back out so that we can I'm gonna do this again, so wouldn't it be nice to just have a callback swapper? Error callback swapper? Or really it should just be a method of the context, right? Yeah. So yeah, let's refactor that out into a function called swap error callback. Error callback with gonna be the same type as this. Actually, Yeah, I do want that, right? I want this whole thing. Hey there, Wrapped. How are you doing? You look at your own code for reference too? Yeah, because I write a lot of stuff and I don't remember it all. Function has to do only one thing and no more, and his name has to explain what it does. Arguments can be one or any that just let him do or not do his job. Yeah, so we're swapping that out with something that will do the job of not reporting anything, right? See, it doesn't really understand that I can use this type there. So I'm just going to teach it that that's exactly the type that it can use. And then I just, this is already boxed, right? I think so. So I just replace it with sort of a bad name. New error callback. I don't really like that name, but let's see what it is. We'll call this old error callback. Cannot find it. Oh yeah. Define context of ingestion module, not the context module. So I just need to import that. And, right. I can't put it inside a impl ignoring this format anymore. So let's make another one. Don't care about this one, but I do care about this one. And we'll move it there. Where did it go? Where was it? Here it is. We're just going to take it out. Put it in the other one. And then I have to do this, right? Declare the, there we go. So it's not replace, right? Because replace takes a T, not an option T. What's the, they don't remember. It's like the version of replace that takes an option T. Is it swap? I'm sure someone will tell me. Usually draw a UML plan first to clarify the algorithm you need, but you start from existing code that's more complicated. It could be just the way I learned badly in the past. I tried to pick up UML for a while. It was hard for me to adapt to that. Okay, I'm just gonna look this stuff up because I don't remember. What we want is to take an option instead of replace. Actually, replace is not on an option. It's on a ref cell, right? Is it replace with? Not replace or replace with. Wait, what's the difference between replace and replace with? Returns the ref value with a new one, return the old value without deinitializing either one. Replaces the ref value with a new one computed from an F function. Okay. Well, there is a swap. But it takes a ref cell. I thought there would be a version that... Oh wait, this is ref cell, right? So T in this case is option T. So then what did I do wrong here? This is already an option. So replace should have worked. Wrong here. Takes a box because this is a... No, this is an option box. What the heck? Thinking about this wrong. What am I doing wrong here? On error is... Oh, that's not a ref cell. That is an option. Okay, so we're not dealing with ref cells. I've just got myself confused. We are dealing with option. Back to option we go. So option has a replace. Does it have one that takes an option though? That's weird. What I would expect that, like, there's no swap. Shouldn't there be a swap? I want a version of replace that takes an option T, not a T. Maybe it's just too late at night and I'm not thinking clearly. Well, I could just say something like map. I can just take it. I can do it in 2 steps. And then I can say if let sum new equals new. I hate doing this. Actually, wait a minute. Why can't I just do this? I hate having to borrow it twice. Actually, you know what? Can't I just do that once like this? Let ingestion equal borrow it mutably, and we're just like shadowing. I forget the word. I have to say it's mutable, right? Yeah, we can do that. So I thought I could do that in one line. I just don't know what it is. It's not replace, because this is an optional. This is also an option, and we're returning it. I really just want to swap. Oh, wait. You can do it with standard mem swap, right? Yeah, can't I do this? Swap. Yeah, can I just do that? Actually, that's not exactly what I want, is it? It doesn't return anything. It swaps 2 things in place. Is it replace? Ah, yes. It returns what it used to have. So I would do that, wouldn't I? Isn't that what I want? Guess I have to do mute, right? That's what I want, right? Replace that with that and returning the old one. Okay, I think that's what I want. Why is that a problem? Takes an argument. Oh, yeah. We need to give it the empty one, right? Oh, I got rid of the empty one. Shoot. Can I just undo until I get it back? Just be careful here. Because it was in here and I deleted it. I have to be careful not to hit any other key or else I lose my redo stack. There it is. carefully take this out. Then redo. Okay, and then go here. And here I have to do a sum, right? And then paste. There we go. So we're swapping the error callback with one that does nothing. And then I have to remember to put it back. So I forget. There's something in Rust where you can like defer, right? Like you can in Swift it would be defer. Like execute this code on the way out. That's what I would want. Actually, there are two places. So it's not when I leave the scope. It's when I leave this for loop scope. Actually, I know what I can do. I can make a new scope. And at the end of that scope, I can replace it. Old original error callback. There we go. That's exactly what I want. So, oh, wait a minute. No, it's not, because that shortcuts us all the way out. So, shoot. What do I need to... I need to make this another function, don't I? Oh, it's too late in the evening for me to do this correctly. How about I just... do it in both places. Then I don't need this. There are two conditions that will restore the original error callback. We'll restore it if we get to the otherwise block, and we'll also restore it if we successfully parse something. Otherwise, errors are going to be suppressed, right? So that means bookmark this, back to it. In our test should pass now, right? Yeah. All right, it passed. And let's run all the tests to make sure nothing broke. So the result of this, if all my tests pass, when I run this again, I shouldn't get any errors when I parse my JSON file now. I'll still have the components marked in red, and we'll handle that in a minute. But first things first, I don't want to see all the noise in the log window. Cool. So we didn't see any noise here anymore. See that? We'll still have errored elements in here. Still see that, but the actual errors are suppressed. So yeah, the second stage here is these failed alternative parsings should be removed from the component tree as if they never existed. Yeah, I can't think of any reason why we want to keep them. But let me look at the tests. Maybe I made a test where I asserted that they would remain. Okay, I had a complicated test here. Bar X, not the first bit. The second bit. I overcomplicated this, didn't I? Okay, so the input was 0101. So if we go through this, the first bit will be 0, so we won't get an error on the first alternative. It should return 42. Is that what we're asserting? Yes. We get that there is an X under foo, and its value is 42. Okay, so then there should be no y because x got parsed correctly. Okay. Is that all we're... Yeah, I agree with the lint. It's cognitively complex. Why did I make this so complex? Oh, because I have alternatives. Okay, so really I should have broken this up into a test suite because I have different alternatives. So in this alternative, the first bit is set, so there should not be an x. Okay, I do make a claim that there's an x. So when I wrote this originally, I must have thought, hey, I always want to see the x because we tried x. So this would need to change to not, right? If I wanted it not to appear. Why? Yeah, so if it's 1010, 1, we would get an error. It would back up. We would ignore that 1, and then we would get a 0. So we should see a y. Oh, I get it. Second alternative means that, okay, so I just didn't have enough comments here. First alternative, x should parse successfully. And then second alternative, x should fail, but y should parse successfully. That's what that means. So we should not have an x. We should have a y. And we have a z because one of the alternatives succeeded, and z is outside of the alternative. The same thing with the first alternative. We should have a z. Yes, we have a z, but we don't have a y. All right, good. So then none of the alternatives should be that neither x nor y. And then what happens in the else? Then, okay, so there is a spam if we, right. So no spam on first alternative or second, but on third there is. And there's always a z because that's afterwards. Got it. Okay. So now that I've modified this test to reflect what I really want, this will fail because it doesn't remove the failed alternatives. So, updated my horribly complex test to match what I want, and then we have to actually do the change. So that's back up here, an alt statement. All right, so going through alternatives here, right? I don't need that space there. So it isn't okay, so what do we do? Okay, so right now we're forgetting that there was an error on the composite, but I'm not doing anything about the part being added, so that's what I need to do next. Hey there, Nisla. How are you doing? Would you like me to explain what I'm working on? I have this fine programmable parser that I've been working on for many years now. Here's what it looks like. And I have a better way of explaining it now because I'm having it parse something simpler that I can kind of walk through. So, working on a program that can parse anything. And the way it does that is you describe how to parse things in its own programming language. So this might look, if you're a web dev, it might this format might look familiar, and that's because the JSON file. Here's what that. Where is the sample? I closed it. Here's the JSON file that we're parsing, right? Here's what it looks like in an ASCII editor. So I've written a description of how to parse JSON in my program's parsing language so that it can go through and say, oh yeah, this is an object. It has 9 elements. Here's the first element. The name is first name and the value is a string John. Second one, is that one. Third one is that one. Fourth one is that one, etc. Here's an interesting one where the value itself is an object and so it can nest. It's got 4 sub-elements. Figured it out. It's parsed every single character to where like I can click on something like the C here and it says, oh, well, that is the encoding of the first character of the string value of the first element of a list, which is the value for children of the eighth element of the object. So really cool stuff. The way that you describe the format to my program, like it has its own language, almost like a programming language. But instead of a program that executes instructions to compute values of variables, this language describes how to parse something. So here's kind of what it looks like here. So it's kind of like a specification for how the overall JSON document is divided into its pieces. So the overall document has some optional white space with an object and then optional white space. So it's overall it's an object, right? And actually, technically it should be value, and that should work too. It should just now say the value is an object. Anyway, an object starts with an open brace, ends with a closed brace, and in the middle you have a loop where you are discarding white space and you parse a name and a value. Name and a value is a name, white space, colon, white space, value, right? So it's kind of like a programming language, except for instead of statements like doing something to variables, the statements are telling the program how to parse something. And it breaks it down as a huge tree or composition. So like you keep going until you get to the elementary things. And in my case, I dig all the way down to individual UTF-8 characters, and I have a special format for that, which uses built-in UI, which is unsigned integer. So it says like if the first 4 bits are all zeros, or if the first bit is a 0, because we take the first 4 bits and we just look at the first of those. If it's a 0, then the next 8 bits are an unsigned integer, and that is the encoding of the character, right? And this, if you know UTF-8, should look familiar because it matches exactly how you'd parse UTF-8. You look at the first bit. If it's a 0, then it's 1 byte. If it's a 1, then it's more than 1 byte, and there's like 4 different ways you could parse it, right? So these are the elementary built-in parsing instructions of my program, and you build more complex things as building blocks on top of each other. So this builds a UTF-8 character, and then a string in JSON is just looping through and collecting those that aren't quotes. So it's a quote followed by something that's not a quote, ending with a quote, right? And they build up all the way to the very top where it's just a huge JSON object. Now, there's some subtle stuff in the language like this alt, which I'm working on today because there's a couple bugs in it. So alt means that there might be something to parse, but if not, break out of the loop. Technically, it's try to parse the thing as not a quote, but if you fail, break out of the loop. So I use it here as a sort of a control flow where we just keep looping until we do get a quote, and then we match it here. Because every time you fail an alternate, you rewind and try something else unless there are no more alternatives, and then you break. There's one way to do control flow, and also for things like value where you have multiple alternatives. That value. You just list them, and it tries them in order until the first one succeeds. And if none of them succeed, then you go into the else. And there you can either do control flow or you can do something else. And here I say, well, it's an invariant. It has to be one of the alternatives, otherwise you can't parse it as a value. And my program uses a couple Rust crates to basically construct a compiler for this language, and it'll compile this format file into memory and then use it as kind of a recipe to parse the actual JSON file that you throw at it at runtime. That's basically how it works. But hey, I have to go let the dog out to use the bathroom, so I'll be right back. And I'm back already. We do not have a dog door, so I am the dog's butler, basically. So, give you guys a rundown if you just joined. That's what I'm working on. A couple bugs with alternate syntax are like when we try to parse things and they fail. So in this case, like this value here, the string John, it first tried to parse that as an object and it failed. It's supposed to back up and try again with the next alternative and forget that it ever tried object, but it still retains knowledge that it tried it, and it gets kind of cluttered because it shows up here and you're like, why does it think it's an object? And it only got one character in and it abandoned it, and then it retried it and saw it as a string. So I'm working on fixing that right now. The other thing that I had just fixed was whenever it would fail in an alternative, it would print out the error message. And we didn't want to see those because those errors are soft errors, so to speak. Like you were parsing an alternative, you weren't sure if it was an object. So if you get an error, just pretend it never happened. Now, if we get a real hard error, like we expected something and it wasn't there, like let's say, for example, just pretend for a moment that we expect the JSON to be a list and not a value, right? That's a hard error. So we will get error unable to parse list, right? Unable to parse the open bracket expected. That's exactly what you would expect to see if you wanted it to be a list and it wasn't, right? But if we're not sure what it is, it's some kind of value, then if it wasn't an object, we don't want it to say, hey, it wasn't an object. We just kind of want it to try the next thing. So we got rid of the printing out the errors, but we still have this lingering like extra little members of the tree that should be pruned off, and that's what I'm working on right now. That is, the alternative stuff is handled here. So we have a list of alternative syntaxes and we try them, and if it succeeds, then we return OK. And this is the thing I just added. So the way we suppressed error messages was before entering the alternatives, we swapped out the error callback with something that does nothing with the error messages, so that when we if we do admit an error, it goes nowhere. And we swap it back with what was there originally on the way out, either here, if we succeed, or if we get all the way down to the else. So now I have to figure out when we parse something and it fails, we need to remove it from the tree. And I'm not doing that yet. So I am clearing the error flag on the parent, the composite, but I'm not going back into the composite and removing the part, which is done. I think it's done inside of execute parse statement. Yeah, we build a part, and I believe that adds it to the composition. Somewhere. Maybe not here. Where does it do it? So at some point it adds it to the keyed children of the composite. Ah, here it is. Yes, we call add part here. Okay, so maybe we just want to skip this if it's inside of an alternative. So maybe we could just parameterize execute parse statement to say like, don't add the part if there's an error. That would be the simplest. We already have a low, sorry, that wasn't what I was looking for. Yeah, I think that's just what I want to do, because this is only called from a few places, right? Right, so a statement can be a parse statement or a different kind of statement that's not parsing anything. And an alternative has a bunch of parse statements in it directly. So there's two places where we could get into execute parse statement, which makes sense, right? That From this one, we do want to keep it, and this one we don't. You know what that makes me think, though? Maybe I should have moved this this register component out to another function, right? Well, the other thing is I could have a different parsing goal. Maybe that makes sense. What if I had a different parsing goal of alternate part? I kind of like the idea of doing it that way. Because then I could put it directly into the grammar. Like that. Let's see if do I use this part thing for anything else? Okay, I would have to have like either part or alternate part, or I can maybe just make a function of parsing goal that says like is formatted or something like that. Data parser, existing format, proprietary. There are two formats here. One of them is existing format, the other one is proprietary. So it's a program that has a proprietary format of describing other formats. So again, let's say you wanted to parse JSON. My parser is programmable in that you can program how to parse certain formats. So if you want to parse JSON, you would, in the proprietary language I invented, describe it like this, and then it would use this and compile it internally and be able to turn that into this. Right? It's using the format description in one language to parse another language. Yeah. Hey there, TS Just. How are you doing? So yeah, there's a little bit of overload in the terminology. When we say like format, there's the format of how to describe another format, right? And then there's the ultimate data that we're looking at in the end, right? Which I want my program to not be hard coded to understand one ultimate end format or another. I want to be able to like, without recompiling my program, I want to be able to like go in there and like either change or write a new format file, give that to my program, and now it understands how to parse something differently. I use Lollipop. So that is a crate made by some people much smarter than myself to build a parser generator. And for the tokenizer, I use Logos. So the grammar for this you describe in the Lollipop syntax. Looks like this. Yeah, I love it. I learned this from chat. So one reason I stream is that it would have taken me forever and I would have probably gone down the wrong path a few times trying to figure it out on my own. But I had some really nice viewers and chatters who said, hey, try Lollipop. Like, it's exactly what I wanted. So this is how you describe a syntax with Lollipop. It looks very Rust-like. You put the code to inject here to generate the values that go into your abstract syntax tree, and these are the statements to match. And you can have more than one alternative. So like a statement can either be a parse statement or an in, two different kinds of parse statement here, or it can be conditional, if else kind of thing. Could be a while loop, could be a for loop, all this stuff. Don't sue you, exactly. You wrote a basic $parser generator for your C compiler? See, you're smarter than me. I took a college class on how to make a parser generator, and I'm like, whoa, this is super complicated. I'm just gonna use parser generators that other people smarter than me have made. So that's why, like in the past, I might have wanted to do it from scratch, but I'm like, this is way too much. I'll just leverage that and build something on top of it. Took you a minute to understand, yeah. I really like that not only is it Rust-like, but someone made a extension to VS Code that understands it. Where was it? here somewhere. Guess I could just search. Yeah, lollipop syntax highlight. So someone already did it. So why do I need to do it, right? The prefix is all in Rust. It's kind of like Bison in that like you have a prefix which is in your target language, Rust in this case, and then you have something that says delimiter. Okay, what follows is no longer the prefix; it's the actual grammar. And then at the very end, I think I list all my with an extern thing. I list all my tokens. And the tokens, like I was saying before, they come from logos. So there's like output from the lexer. It looks like this. So like you just have a whole bunch of logos macros that define certain elementary things, some patterns, and then it's just a bunch of either reserved words or you have a bunch of regular expressions to match. Here's how you match an identifier. Here's how you do a floating point. Signed integers, right? Yeah. So it's really nice in that it's logos is actually all macros, so everything's in Rust. You just have some really scary looking regular expressions for a few things. And then lollipop is almost all Rust or Rust-like. It's kind of at that boundary between part of it's Rust and part of its grammar language. So I like it. Having to log yourself to using tokenizing and parsing generators, or otherwise, what's the point of a project? Is this for the fun of learning? Well, for me, the fun is I'm leveraging a parser generator to invent my own language for parsing other things. So I'm using it as a springboard to do what I really care about, which is making a very, very flexible parsing infrastructure. So yeah, right now I'm working on suppressing alternatives that fail. So once again, like in JSON, you might have a value, and it doesn't know off the top of whether it's which one of these it is, right? So in my parsing grammar, what this alt says is try to parse it as an object. If it fails, go back, try to parse it as a string, etc. Only if none of them work do you actually generate a real error. And what I want to happen is if any of these have an error, I don't want it to report an error to the GUI because they're sort of expected that they might error out. And if any of these fail, I don't want them to show up in the final output data tree. So I did the suppressing errors a little bit ago, and now I'm working on the data tree pruning. So right now, for example, here's a value that's actually a string, but it first tried to parse it as an object and it failed. It got to the first one, which was open brace, and it wasn't an open brace, it was a double quote, and it failed. And then it backed up and succeeded in parsing it as a string, right? And actually inside of there, as it was parsing the string, it was looking at the characters and trying to see that they were not a quote, and then the not a quote rule failed on the actual end quote, and then it backed up and interpreted it as an end quote. So again, here's another one where it got into the output data tree, and I didn't want it to go there because it was a failed alternative. So I'm working on like pruning the tree so that those don't show up. And this is all happening inside this alt statement, and then when we parse, and then when we're done parsing, here's where we register the component if it has a name. And this is what I want to suppress if we're doing a failed alternative. What you did is far more complicated to implement. Hey, you know what? Like, I'm doing this for fun as a hobby. If I was doing this for making money or for business, I would definitely try to optimize my time. But when you do stuff for fun, it's whatever you enjoy doing. So if you enjoy doing it from scratch, makes sense. Even if other people have done it before, like you don't have to reuse something if you find doing it yourself to be more fun. Yeah. Also, I think that a lot of the time, the end goal is not really what matters so much as the journey you take getting there. Like I'm learning a ton of things along the way. Like I was going to implement this alternative suppression of the errors by having a flag in my context that says, are we in an alternate statement or not? And then someone in chat is like, oh, why are you doing that? Just decorate your error callback so that when you're in an alt statement, just have it do nothing, and then on your way out, you can restore it to the way it was, undecorated. Technically, we're not decorating it, we're replacing it, but we could have, we could have put the function inside of here and just not done anything with it. I thought it was simpler just to take it out, to swap it with an empty one and swap it back, but yeah. Yep, the journey. Journey before destination, right? Okay, so I was exploring the idea that I have this thing here called a parsing goal. And right now I only have 3 kinds of parsing goals. So generally a goal of parsing is to get a part in the output. But another kind of goal is you're parsing something to throw it away. And I have that a lot in the JSON stuff for things like white space. I don't care about seeing it in the output. So whenever you see a minus sign in front of a name, it means we are ignoring. The goal is to ignore it, right? And then we have a third goal, which is look ahead. And I do that in some other places too, as a convenient way of scanning ahead to see what decision we should make. That came in, I used it here in UTF-8, is I scanned ahead 4 bits, and I use it as the data we need to make the decision on which path to take, because as we saw with UTF-8, there are 4 paths, there are 4 ways to parse it, depending on what the first bits are. So it kind of, it allowed me to write the descriptions to sort of match the chart, the table that's in Wikipedia, which is kind of nice, right? Actually, here you see all 3 kinds of parsing goals. There's the look ahead, there's the ignore, and then all the other ones are just parts. The UI, by the way, stands for unsigned integer. That's the built-in elemental parsing where you just take bits and you assume, you treat them as an unsigned integer. So yeah, anyway, I was back and hit the right key combination. Why is this not working? Not hitting the right keys? There we go. I was thinking about adding a 4th one called alternate part. It would be like part, but if it's erroneous, if the error flag was ever set, we skip the code right here where we add it to the parent. So then we could focus on this line and only do this if it really is part and not alternate part. Actually, no, the other way around. It would be something like if statement goal is part, and that would return true if it's part or alternate part. And then we would say if part.error, part.borrow.error, or I guess we would say if not error or parsing goal part equals statement, something like this. I'd have to clean this up. We'd do something like that where we would add the part, but only if there was no error or the goal was to actually have a real part. Is part sort of a bad name here? The way you did parsing is you have no parsing errors that aren't fatal. Errors are only created the parser cannot recover. Right. I'm kind of doing the same thing, only I have 2 categories of non-fatal error. So one non-fatal error is I couldn't continue within that subcomponent, but I can go back up and then skip those bits and proceed on past that. That's non-fatal for the whole composition, but the subcomponent had to stop. Yeah, but yeah, so the difference is on mine, I have a second category of error where we don't know yet what the format is, because we have to either look ahead or we have to try. At some point, like I was going to do this all with look aheads, but at some point I was like, I know I'm going to run into some complex format down the line where you just have to try going down one path, and if it fails, you have to back up all the way and try a different path. And I thought the most succinct way of doing that is to, at the top level, have alt, where you have multiple alternative paths, and you just try one until it works. So that's where this alternate path thing came, what I came up with. So far, it's working okay. Only I have these weird things about, do you keep the paths that you attempted but failed? Do you keep them around? And at first I was like, yes, but I'm like, they kind of clutter things, and they were really only experimental paths, and the experiment failed. What did we learn? It's just not that path. So anything that we parsed partially in that path really was invalid anyway. So we don't really. It's as if we didn't even try that. In other words, like if I rearranged these so that the correct one was always first, then we would never see the others anyway. So the order really shouldn't matter, other than what's the most likely first, right? So a better thing from part would be like, is not look ahead or ignore. Should persist. Something like that. If the goal should persist component. See, yeah, my naming is not that great. If the goal is to persist the part, then if there's no error or the goal was to make a part, then we add a part. So the idea would be, if I have alternate goal, parsing goal alternate should persist if it succeeded. Yeah, I don't know about the names, but that was the idea. Let me put it back to where it was. Okay. Thing is, I'm not sure about how many places I used this parsing goal part. I want to kind of look through them and see what the impact would be adding another, basically adding another variant to parsing goal. What would be the effect? Cool side effect of the no backtracking model uses that your C compiler is currently an ON streaming compiler. Yeah. Well, one trick about being able to back up without really backing up is you push back into a stack off to the side. The stack would be the already ingested input that you pile up to use again on your next try, right? I've seen it done that way. So you could still on the outside look like it's streaming. You just internally pushed it back onto a stack to try again to use later. Would you consider that cheating? Like, you really are backing up, but it just doesn't look like it on the outside. It would break your ON model though, because you would be processing the same characters more than once. See, but then how would you avoid look ahead if you couldn't back up? You'd have to look ahead, right? So is looking ahead okay and doesn't impact your complexity? Or maybe what you're parsing doesn't require look ahead? Because there are languages where look ahead is not required. Everything is deterministic bit for bit, right? Not doing that either? Okay. I don't know what it would take to make a C compiler, but maybe at every character position, you'll know what comes next, right? I'd have to stop and think about it. All right, there's my enumerated type with its variants. I could print it there. Okay, that would not be impacted. Not error and goal is apart. The callback, right? Yeah, okay. This is if we don't have a name and the goal was to make a part, then we use the format as the name. That would still apply. Okay, that would be apply for alternates also. See you, Nightshade dude. I should probably end soon too because I've been going for almost 4 hours and I'm starting to lose my voice. Getting better at keeping my voice though. 2 days ago I only went 2.5 hours or 2 hours or something like that and I lost my voice. Now I'm going 4. Next time it'll probably be 6. Yeah, I think I'm going to end soon, but let's try to get this alternate parts removed from the tree if they fail. I'll try to get that done and then we'll call it a night. Imagine you're in the top scope. No functions yet, only declarations. There's a couple valid bits of grammar, functions, and variables. So consume the next token, tokenizer, and we run a switch statement, checking every valid. Right. So it's kind of like how the grammar I have works, right? It has like a state machine where if it knows the next, if it sees one token and it says, okay, it must be some kind of unary operation, but we haven't parsed the expression yet. So it's got a cursor. Okay, we saw the not. We know the next thing is an expression 0, but we don't know what kind of expression 0 it is. So you must have like you must have a list of all the possible places where the token you just got would be valid, and you just kind of like you consume tokens until you get down to one alternative that you know it must be, and then you reduce it. Shift versus reduce, right? I see how that works. Yeah, my parser is fundamentally different from that. Does it have a grammar called var or function? Yeah, so that's how my grammar works too. Where do I have stuff like that? I guess I don't actually, but I see what you're saying. Like you'll have 2 different things that it could be, and you just hold on to both, and you wait until you it narrows it down, right? Doesn't work in every kind of grammar, but it works in C. So yeah, that doesn't work in C++, right? Because there's some context you don't know until you've scanned way far ahead, and it gets really complicated because the number of tokens might be open-ended. Yeah, cool stuff. This is the kind of thing that like I remember from a little bit from college, but not enough to do it myself. So that's why I use Lollipop. Anyone who didn't see me post it before, this is what I use that I did not write this Lollipop crate to build the compiler that's in my tool. So when I show like the grammar, this is all written in a syntax that's used by the Lollipop crate to generate a compiler that's part of my program that understands the language that I invented here. You didn't get this in college. You're also not looking up anything on how to do it because you want to figure it out by yourself. Do you know about the Dragon book? So if you didn't do it in college and you wanted to learn it on your own, at least back in my day, there was the Dragon book, and you just read that because it's basically the same as the class. Building a local power, just the standard, no other resources, hard mode. So do you allow yourself to read like a book on the theory at least? It's like the compiler, the Dragon book is a famous book about compiler theory, and they'll walk you through like shift, reduce, and all that stuff, and then you can still do the hard stuff. You just pick up some of the theory. If you're coming up with a theory on your own, that's real hard mode. Very admirable. I would never be able to do that. Okay, so more and more as I think about it, the more I am convinced that I am going to add here something else. But I want to make that word part different. I'm going to rename that. So like maybe fixed part versus alternate part? Something like that. Why it's taking you so long because you're pretty much doing that? It's cool when you figure out a clever solution, realizes, well, it's not novel anymore, so it's not like you're the first person to come up with it. But it must feel nice when you come up with something and then you learn later that that's what other people came up with too, and so you're like, yeah, I'm on the right track. There's that weird problem I'm running into now again, where I can't click past about there, and I don't know why. It's some bug in the virtual machine. Maybe it's VS Code. What if I close VS Code and open it again? No, it's not in VS Code. It's like the OS. It doesn't know I'm clicking here. I have to click over to the, I can click over to the right, but I can't click to the left here. I can drag, but I can't start clicking. Oh, now it's totally frozen. See how the circles stop spinning? The VM is totally hosed now. What I get for playing with the thing. So do I wait for it? Last time this happened, it took like a good 5 minutes before it came back. Only clickable after paying for the $9 DLC update? Yeah, I don't know. So I don't know, is this a bug in Xubuntu, which is the guest OS? Or is it a bug in Parallels, the host VM manager? This didn't happen when I last streamed like a year and a half ago, so... And I didn't update the guest OS, so I'm guessing it's some bug in Parallels. I don't know what to do other than wait for it to get unstuck. I could kick the VM, completely close it. What happens if I send it a keystroke? Or pause and resume it or something. Very hesitant to do anything with it. Time to switch to Vim? No, it's the whole what OS I stream from. I liked streaming from a VM because then I don't accidentally share stuff on my private, like if I opened up Finder or something, or I open up a browser and it shows, where I am. Happy New Day? Yeah, it's midnight here. It's CPU pegged right now. Oh, I'm getting the spinning pinwheel too. What would really suck is if I lose the drive and I would lose everything I worked on tonight. I'd have to go watch my own stream to recover the data. Oh, is it recovering? No. I am going to tell it to close. And then resume. Oh, yeah, now it captured my... Okay, oh, is it back? What to do here? The VM is just stuck. It got into a state before I was streaming where this happened, when I was setting up, and it actually captured the mouse and keyboard and wouldn't let it go. And I'm like, what the heck do I do? Do I just reset the whole the whole machine that the VM is running on? And as I was about to do that, it just suddenly unlocked and started going again. That's what I was hoping would happen now. Actually, the time down there at the corner changed. Hold on. I have to update the window. See, it says it's 10 after now. Oh, wait, I can switch windows. So hold on. Then what I'll do is I'll just sudo reboot. There we go. So what I found is that when it gets into these weird states, I just reboot and it comes back up fine. So annoying. Didn't do this 2 years ago. Hey, before it gets hosed again, you know what I should do is I should copy the files off so I don't lose anything. So the way I do that is I do send. And now I have a copy in case it gets hosed. I did have a magnifying tool. I used that like years ago, and I just kept it up in the background. What's it called again? Magnus. It's called Magnus. I haven't used it for a while. I just keep it on like way off on one of the other desktops. Okay, back to work here. Before I got stuck. Find all references to part. Oh, I need to find where this might be in the grammar too. Yeah, there's one place. That's only in one place. Actually, you know, that's good because take that back. It's not good. I just realized something. Parse statement is used both in statement and in alternates. Where's alternates? Alternates. Or alternatives? No, it's not alternatives. It's here. Parse statements. Spanned parse statements. So this is hard-coded to be a part here. Even if I wanted it to be alternative part, I can't do that because there's no way to pass in parameters like that. I'd have to like do it after the fact. I'd have to, before constructing the alt statement, okay, either while constructing the alt statement, I have to go in and update all parse statements to turn parts into alternate parts, or maybe just the fact that we're in a alt statement, we know it's an alternative part. Okay, so that's another, I guess that's another way to do it. Is here that we're executing the alternate statement. When we call this, we can just tell it that, hey, yeah, I think I'm overthinking it. I think I just need to have a Boolean here. Is alternate. I'll just do that. And then what we do down here is we get down here and we say if is alternate. If it's not an alternative, or the part.borrow, if it's either not an alternate or not an error, then we add it, right? So if it's either if it's both an error and an alternate, we don't add it. Yeah. Then I just need to follow all the errors here. So for a statement, it's not an alternate. Or an inside of an alt, it is. I just noticed something. This second argument is bitstream. Is that something we can use instead of that flag? Maybe. Bitstream here. Okay, so that might be false. So bitstream might be something or nothing. In an alternate, it's always nothing. Why is that? Why is bitstream false for an alternate? Not. Oh, I know why. That's if it's. I added that recently. That's if it's a different bitstream. So I use that here. To record that it is. Where do I say that? I forget. It's not important right now. Are you parsing your MVE file? Hey there, Quantum Apprentice. I was going to do the MVE, and I have the. Let me restore it again because I lost it when I rebooted. I have the MVE format here, but I was doing JSON first. I'll get to it. But hey, since you're here, I'll show you what it might sort of look like. If you've probably seen JSON before. So imagine what I'm about to show you, not being JSON, but for MVE, what it might look like, right? So for JSON, here's what my parsing language for my programmable parser looks like. So it kind of looks like you're making functions, but instead of calculating values and setting variables and printing things, the statements are saying what to parse and what to do with it. So like optional whitespace, the minus in front means we're discarding it. We're dropping optional whitespace. And a document is a value, and a value is alternatively either an object, string, list, number, true, false, or null. And like back to optional whitespace, like the way you parse optional whitespace is you go in a loop. You're done if you either don't have any more bits, or you parse a character and it's not a whitespace character, so you have a break. So it's like we're still executing functions and doing work, but instead of collecting and using values on the stack or the heap, we're actually consuming bits of input and then spitting out what they should be interpreted as. So like when I run this in the terminal, actually it's broken now. So if I run the last thing I built, there we go. So here's the input JSON file, and the output looks like this. It's like a data tree, and you can click on things. So imagine how that might look like with MVE is, the way I understand that format, it's a bunch of blocks. And so there would be like a blocks, and then there'd be in brackets the number of blocks, and then you'd be able to click on each block, and inside each block there'd be an opcode, and then like, depending on what the opcode is, the elements that follow that would be specific to that kind of opcode. So that's where I would get it with MVE. Probably not going to get there tonight, but maybe tomorrow, because I'm almost done with JSON. Right now, what I'm working on is see that row in red object? It tried to parse this string as an object and failed, and then it backed up and tried again with string. And I have a bug where it doesn't drop the alternatives that didn't work. Yeah, so that's the whole point of this programmable parser, is that you can visually inspect not only like what the data means on the right here, like how it's interpreted, but you can click on individual things and show like where it is in the raw data, and you can actually go the other direction. I could say, well, that 27, where did it get parsed? And it's like, oh, it got parsed here as in element 4, it's part of the value, right? Here's the overall value is 27. The reason why there's a whole bunch reds is that bug again, where it tried to parse it as an object and a string and a list, and it failed. But it eventually succeeded in parsing it as a number, right? And actually, even when it was parsing it as a number, it first saw the 2 and then the 7, and then it saw the comma and said, oh, a comma is not a digit, so that's an erroneous digit, and it backed up. It should not have, so it should have dropped the 2, it should have dropped all of that and reduced it to just be Element 4 is a value with a number with the digits 2 and 7. But I really like that I can describe how to parse something, and then I can have it appear in the hex editor and click on a byte and say, oh, where is that? Oh, there it is, right? And I did it with GIF files, I did it with JSON, and MVE is probably going to be next. So yeah. So in order to make the parser programmable, it has its own language, and so it has its own compiler for that language, and so that's kind of what I was going over before. So yeah, I'm just trying to clean up those red bars that are not supposed to be in the GUI, and then I'll probably call it a night. Which hex editor? I made my own. So let me show you. This whole GUI is written using eGUI. So you might know about eGUI. It's based on IMGUI, which I think you've used. So it's the Rust equivalent in spirit to IMGUI. So it's an immediate mode user interface, and so the library has built-in things like splitters to split regions up, and you can drag and resize them. But you can make your own GUIs, and so basically I have a class in Rust that divides the screen up into the rows and columns. And I can show you real quick what it looks like. Hex. I guess it would be lib.rs in the hex editor, right? So for example, when you draw, you first draw the header, and then you make a scroll area, and you draw the main area. The header was the, if I flip back to running it, it's this bar with the numbers on top because it's fixed. So as I scroll, it's not affected by the scroll. So it's really two regions. There's the header, and then there's the scrollable region, which has the row columns, the row column, and then the content column. So it's immediate mode is like it's like you're giving a recipe. First, draw the header. Now allocate some space because I want to make a vertical scroll area, and inside that scroll area, show this. So like draw header is pretty easy to understand. We get the width and the height of the text font we're using, and then for all the columns, we tell the UI, hey, we want the painter, we want to paint text, paint it exactly here, align it this way, this is the text to draw there, here's the font to use, here's the color that we want white, right? Pretty straightforward. So we're drawing the hex bytes and then the ASCII bytes in different places. And I try not to have very many magic. I still have some magic numbers, but a lot of them are constants here, so I can tweak them. But yeah, you first draw the header, and then the main body is drawn. I keep going back. In this main area. So the main area has a bunch. It has some logic to do the scrolling magic. It draws highlights. There's the bytes to draw in the actual visible area. And where's the column where we draw the things off to the side? I guess that would be draw bytes. Yeah, so we draw the offset column, which is the numbers on the left-hand side. And then we actually get the data to draw from there's like a cache. We get a line of the cache, and we get the bytes out of that, and we paint them. So it's very low-level, immediate mode UI. Not much to it. It's not. I call it a hex editor, but it's not really an editor yet. It's read-only. It supports scrolling around with the offsets. You can highlight regions, and you can. There's callbacks when you click individual bytes, so the rest of the program can figure out. Oh, you clicked on byte 9.5 hex or 9.6, and then the rest of the program figures out what you clicked on and updates the other panel, and it goes in the other direction. I can click here, and it'll highlight there. It'll if I go down far enough, it'll scroll to scroll to there. It'll scroll up, scroll down. The most complicated part actually was drawing these curves, because eGUI doesn't have a way to fill a curved rectangle. I had to do like really like every single little turn. I had to hand code in the graphics library's primitives. It was a pain in the butt. But I like the end result. I just like, I think it looks nicer when you have curves rather than like straight edges. Yeah, pixel by pixel, pretty much. So the cool thing about eGUI is that it's not the lowest level. It has to sit on top of a backend, and the backend I'm using is WGPU, right? WGPU? Yeah. So it's a portable graphics library for Rust. So eGUI sits on top of WGPU using a well. So in my text editor, it just depends on eGUI, but my overall GUI binds the backend using eGUI WGPU. So the cool thing about that is eGUI has other backends for things like the web or ePaint, or like, there are other ways, other low-level libraries you can use to actually do the drawing. So it makes it more portable. I could take this app and run it inside a web browser just by switching the backend from WGPU to whatever it is on what do they have? A WASM, WASM, right? There's a WASM equivalent. Either of WGPU or eGUI I wouldn't have to change hardly anything at all. It would just work, which I really like. So, yeah, let me get back to the one remaining task of the night because I'm up way too late and I want to finish this. So it was here, right? When we're right. I added this thing so that if we're inside of an alternative, that if there's an error, it won't add the part. Actually, does that mean it will build now? Am I done? I might be done. That would be sweet. Because I'm getting tired. I'll probably stream tomorrow. It'll be a different time. Monday, Wednesday, Friday, I'm thinking evening specific, but on the weekends I can go anytime. So probably in daytime for me. Hey, I think it worked. Oh, check it out. Look, it now doesn't show that it tried to parse it as an object and failed. It just says the value is a string. Nice. Yeah, so MVE, I think I'm going to do that tomorrow. So what I was planning to do is when I actually get something working, I'll probably post it on your Discord. And what I'll do is say, hey, check out, here's what it looks like in my parser's language. It'll look something like this, only it'll be much more recognizable to you because you'll be like, oh yeah, there's the opcodes. And I don't have a visualizer for the actual images or the motion picture, and I don't have a renderer for the audio, so you won't actually see the decoded frames, but it'll show you a breakdown like it does here for JSON. So you'll be able to focus in on the bytes that make up any particular frame or block or whatever. In the future, I want to have visualizers so that if when you parse something, you end up with a 2D image, that you can actually show it on the screen somewhere. Grok can't even get the opcodes yet. I thought your Grok got pretty close. It just got kind of snagged on some of the details of because I saw some of those blocks are like, you take the previous image and you just move a block around, and maybe it's like it got that a little bit wrong, and so it has the offset a little bit wrong. Oh hey, the error's gone. I know. Isn't this? See, this looks cool. No more red blocks. We can verify I didn't completely destroy the error reporting by actually putting a bug in here. I can say, hey, we want a string, right? Now it will give me a red thing saying, hey, I tried to parse it as a string, but hey, look, that's not a quote. So yeah, we're quote was expected, unable to parse a quote, unable to parse a string. Is exactly what I wanted to see, right? So bring that back to value. Now when it reloads, it's like, hey, yeah, look, the value, it's an object. It's got 9 elements. First element is named, see, this one thing I need to do is I want the name first name to show up under the value column. I can't do that yet because the way I assemble the name, it's a sequence of UTF-8 chars, and I don't have a built-in type for that, nor do I have a way to assemble a string from a UTF-8 character vector. I'm missing that right now. So that's on my list of things to do, I think. If it's not, I need to add it. Let's see. Yeah, so I did that one. That should have been a do not pass, not a so not pass. Oh, I need to fix that. This one I just did. Do not populate parts that failed in an alt. Yeah, so this is the one. This one covers showing first name here because I have to take these individual characters and like reassemble them as a string type in my parser's output composite structure. Since I don't have a built-in UTF-8, but I need to have some kind of conversion or maybe support UTF-8 natively or something. Yeah, so I need to do that, and then there are two other bugs that I haven't fixed yet, and then I need to get to MVE. Array of UTF-8 instead of UTF-8 string. Well, I kind of want here's what I kind of want. So like let's go back to GIF, right? If you remember in GIF, I guess I put the GIFs under stage, not examples. Yeah, like the Pog slide GIF. If we go to that first block, which is just special purpose block, it's got an application identifier, and you see how the Netscape shows up here as the string Netscape. That's what I kind of want for the JSON when it actually is a string. I wanted to reassemble the string and make it the value of that, of that string in the value column. But right now, the native string type in my parser is not UTF-8 string. It's like the more primitive, like ASCII string, like where every character is hard coded to be 8 bits long, right? So I need to extend that to UTF-8 or have a way to cast UTF-8 characters back into a string type and then reassemble the string character by character. And that's going to take more work than I want to spend tonight because I want to sleep. But that would be my goal, is reassembled strings should show up in the value column for my JSON thing. Let's go back to JSON. Sample JSON. Open config JSON. Toml. Yeah, so this string that says John, I wanted to actually say quote John end quote up here. And that's my goal. Here's the thing with AutoMod. I guess I can allow that, but I don't want people to abuse the language too much. Array of equal width versus variable width. Well, see, technically, there's no reason I can't reassemble a string with UTF-8 in there, like even with emojis, because Rust strings are also UTF-8, and my parser is written in Rust. So it's just the artificial limitation I put in my own code that says that a string is a bunch of 8-bit or 8-bit wide characters. I need to break that. I need to fix that, and I just haven't done that yet. But the individual characters are parsed correctly. So I have an example in here where I put an emoji right here. So this, if I show you what it looks like in VS Code, it's this favorite emoji, and it's like that that not smiling but not frowning face. My parser does parse it out as a single UTF-8 character with a very large code point, and it remembers the encoding the individual parts that made that up. But I just don't have the last step, which is to take that code point and turn it back into a character to show on the screen here. Rust has everything I need. I just haven't connected the dots yet. You wouldn't rely on Rust to be iron? Good one. Yeah, so if I were to like seriously use this tool for real with JSON, I'd want to have the strings shown here in the value column. I mean, I think anyone would. Yeah, and there are a few other rough edges, like the fact that I had to have an underscore next to the true there. I kind of want it, instead of the value 4 there, it should just say true. There was, I think the problem with that was there was a bug in how I interpret alternates. Yeah. The problem here was that I believe it sees value as only having one element called true, and that doesn't itself have a value. So it digs deeper and sees the characters that made up the value true, TRUE, and it prints those. And it says, okay, well, then true is just an array of 4 things, and they happen to be those characters, right? The bug was if I actually tried to return something from expect literal, it actually broke things. Like, if I say return literal, I think that'll actually break it. Maybe not. Maybe it just works. That'd be cool. Where was that true again? Oh, it just worked. Well, heck. There it is. True. Would be even better is if it was really the Boolean true, not the string true. Actually, to do that, what I would do is I would wrap this with something like bool. Bool, yeah. This is what I had started with, and then I ended up doing something else. But instead of expect literal, I would just have bool. And then it would return true or false. And the way I would do it is this. I think this is the sticky point here. It's like, I don't have a way in my syntax to test which alternate actually succeeded. Like, what I'd really want to have is another name here or something like that. How would I do this? How would I want to do this? Well, first let me see if this works. This should work. No, it didn't work. Didn't work, why? Because I need to have an else. Error expected Boolean. Now, like, it'll pass that alternative and then try something else. So the problem with this, I think, yeah, is I didn't have a syntax of like turning it in. Like you would say, I'd want to have something like, I don't know. Like it has to turn it into true. You know what I'm saying? Turn this into the actual built-in value type false. Rather than carrying, but right now what it does is it carries the return value of expect literal, which is literal, right? Expect literal doesn't know the difference between true and false. It doesn't know what type to give. We only know the type within the context of bool. But I need to interpret which one passed and have it emit a certain value. And yeah, I don't have a way of expressing that right now. Need to go deeper, I know. I need to think about that. Maybe something will occur to me in the middle of the night, and I'll be like, I'll wake up in the middle of the night like, oh, that's how I'm going to do that. I don't know about you guys, but that happens to me a lot. I'll go to sleep like not knowing exactly how I'm going to design or implement something, and then I'll wake up at 3 a.m. like, oh, I should do it that way. Like my brain is still working when I'm asleep. Well, I'll keep working. I'll keep thinking on how to fix that, and then we'll try. So Quantum Apprentice has been working with this format from Interplay that's used for video and audio movie stuff for older games like Baldur's Gate and Fallout series. And there are some sample files that you can download actually, and one of them is like a nice logo that Quantum Apprentice showed in his stream. And I won't be able to show that, but I'm like, hey, this would be an interesting challenge. Let's see if my parser can also read these formats and interpret them correctly. I'll probably be working on that tomorrow. So I hope you guys enjoyed watching. I'm going to go fall asleep now. Let's see if anyone I know is streaming and I can raid them. I don't see anyone that I know streaming programming right now. So I think what I'll do is I will leave it to you, the viewer, with your best judgment where you'd like to go watch next. And I will just fall asleep off stream. I will see you guys tomorrow, okay? Take care. Bye. Thanks for watching.